Ladies and gentlemen, it is my privilege to welcome you to the 8th annual UWI Math Fair. This year, our theme is Island Innovators, Mathematics Powering the Future. Good morning, everyone. My name is Kiran Dayanand, and I will be your live stream moderator for today's event.
Please pay attention to the following important safety briefing, which will be followed by the national anthem.
So, to everyone on the live stream, you are invited to post questions about the Math Fair in the comment section, and we will do our best to answer as many of them as we can. Today's proceedings are as follows. The opening ceremony will commence shortly, and joining us for that will be the Chief Education Officer of the Ministry of Education, Dr. Peter Smith, the Dean of the Faculty of Science and Technology, Professor Adesh Ramsubag, the Head of the Department of Mathematics and Statistics, Professor Sridhara Rao Gunakala, and the Chief Coordinator of the UWI Math Fair, Dr. Kenaton Daga. Following this, we would like to honor some of the biggest contributors to mathematics at the university over the last year. Their research has made excellent strides in benefiting the wider society. Okay, so we've got a full day of exciting activities lined up, all inspired by our theme, Island Innovators. Be sure to catch our annual Math Feud here in the Engineering Lecture Theatre. Over on the LRC Greens, dive into fun-filled mix of games, puzzles, and riddles. Head over to the JFK Auditorium to check out our booths and hear from our sponsors. And don't miss one of our newest additions, Math Bingo, happening in the JFK Lecture Theatre.
Exit the building in a calm and orderly manner and gather the assembly area where you will receive further instructions.
Can we now all please stand for the national anthem? Thank you. Please be seated. Dr. Indra Harak Singh, President, Trinidad and Tobago Mathematics Olympiad. Professor Sridhara Rao Gunakala, Head, Department of Mathematics and Statistics, the Faculty of Science and Technology, the University of the West Indies, St. Augustine campus. Dr. Philbert Morris, former Vice Dean, Faculty of Natural Sciences, which is now the Faculty of Science and Technology, and former head of the Department of Mathematics and Computer Science, which is now the Department of Mathematics and Statistics at the University of the West Indies, St. Augustine campus, who is indeed our featured speaker, all specially invited guests, representatives from our valued sponsors, CIBC Caribbean, Unipet Limited, Domino's Pizza, Bermudez Biscuit Company, and optometrists today, faculty, staff, and students of the University of the West Indies, St. Augustine campus, teachers and students of all schools represented here, ladies and gentlemen, members of the media, good morning. With some more energy, please. Good morning. Thank you. My name is Asad Muhammad. I am a lecturer in the Department of Mathematics and Statistics in the Faculty of Science and Technology at the University of the West Indies. and I will be your Master of Ceremonies this morning. This math fair in 2026 is the 8th iteration of the math fair. It aims to foster a passion for mathematics among high school students. When it began in its inaugural year, it had over 1,000 participants, and over the years, the number of attendees has continued to grow. This year, we are very happy to announce that we have over 3,000 registered students. And in our poster competition, we have over 75 entrants and a further 48 entrants in the creativity competition. So please, you students, give yourselves a round of applause give yourselves a round of applause for your active participation in this effort. We must understand that an undertaking of this magnitude requires support and significant planning. And so we are immensely grateful to our corporate sponsors for that support. Sponsors are, and I mentioned at the beginning, CIBC Caribbean, Unipet Limited, Domino's Pizza, Bermudez Biscuit Company Limited, and Optometrists Today. We deeply value their partnership and their commitment to this university. Again, please join me in showing our appreciation for their support. To begin the formal program, it is my distinct pleasure to welcome the head of the Department of Mathematics and Statistics at the University of the West Indies, St. Augustine, Professor Sridhara Rao Gunakala, to officially open this math fair.
Good morning to all. Observing all protocols. It is both honor and pleasure to welcome you to the 8th Math Fair 2026. Basically, it is a 9th one, but in the pandemic, we celebrated 2 years in one year in 2021. So this math fair hosted by the Department of Mathematics and Statistics with collaboration with our Faculty of Science and Technology at the University of the West Indies, St. Augustine campus. This year, we gather powerful and forward-looking theme, that is Island Innovators, Mathematics Powering the Future. This theme simply reflects but profound truth. The future of our islands, our economies, our environment, our technology, and our societies will be shaped by mathematics. I will tell you later why the role of mathematics shaping that important goal. So, Mr. Asad Muhammad announced a number who are the number of registered for this year. And this is not just a number. It is a statement of trust, enthusiasm, and belief in mathematics. So, if you are counting from 2018 onwards, now it is, mathematically, we are seeing exponential growth. In today's rapidly evolving world, mathematics is not optional. It is an essential for our future. Why it is essential for our future? It underpins artificial intelligence and machine learning, that is nowadays a trend in all disciplines: climate modeling and environmental sustainability, renewable energy and smart infrastructure, financial, technology and cyber security, engineering, healthcare, logistics, and innovation. For all these one, what is the behind? You know what you studied in your CAPE level, undergraduate level, that is nothing but the foundation of the linear algebra and statistics. It leads to mathematical modeling, cyber security. So all these are the underground is these type of courses. So this year students are engaging through over 30 interactive mathematics booths across the surrounding our JFK, LRC Green, and nearby all places. And large-scale games such as Math Bingo, Math Relay, and Jeopardy, and inter-school competition, including Math Quiz, Math Creativity, Mathematics and Statistics Poster, Design Competition, Teachers Game Design Challenging. So, before today alone, we received over 120 competition submissions, demonstrating a remarkable creativity and enthusiasm. Importantly, students also experience library tours, exposure to academic program and research pathways, interaction with faculty, alumni, and industrial professionals. This is how students begin to see themselves as future innovators. To our students, this fair is for you. Ask the question, try something new, make mistake. It is about thinking, exploring. It is about thinking, exploring, and persisting. So you are the island innovators who will design sustainable cities, build economics, proper corridors, protect our environment, and lead our region forward. So to our teachers, thank you for your dedication and belief in your students. To our sponsors and parents, your support strengthening this initiative year after year. To the organizing committee, faculty, staff, and volunteers, your commitment has transformed vision into reality. Ladies and gentlemen, the UWI Math Fair is more than an event. It is a movement, one that transforms how mathematics is perceived, experienced, and valued. With that, it is my great pleasure to officially declare the UWI Math Fair 2026 open. Thank you and enjoy the fair.
Thank you, Professor Rao. The Department of Mathematics and Statistics is one department within the Faculty of Science and Technology at this University of the West Indies. Now, mathematics and statistics, they serve as the universal language and the structural backbone of the natural sciences. They provide the logical framework and the analytical tools necessary for the natural sciences to translate empirical data and observations into precise models and to quantify uncertainty. And so I would like to invite to the stage Professor Adesh Ramsubeg, the Dean of the Faculty of Science and Technology at the University of the West Indies, St. Augustine, to give a welcome address.
Thank you, Chair. CEO of the Ministry of Education, Dr. Peter Smith, featured speaker, Dr. Philbert Morris, Director of the UWI School for Graduate Studies and Research, Professor Duraisamy Saravana Kumar, Head of the Department of Mathematics and Statistics, Professor Sridhara Rao Gunakala, other heads of department, deputy deans, members of the UWI community, members of the media, parents, teachers, and most importantly, students. It is truly a pleasure to see so many of you here this morning, and knowing that there will be thousands of more students visiting us later during the day. Thank you for choosing to spend the day with us exploring mathematics. For many of you, this may be your first visit to the UWI campus. And we hope that by the end of the day, this place will be a little bit like home, because we look forward to welcoming you in the next few years as students. In our ever-changing world, increasingly driven by artificial intelligence, mathematics will become even more important in the future for careers ahead of you. While AI can automate many tasks, human reasoning, judgment, and interpretation, as well as quantitative skills, such as data analytics, will become more valuable than ever. In fact, as Professor Rao indicated, AI itself is fundamentally driven by mathematics, with computing as its engine and data as the fuel. Today's Maths Fair is about building excitement around mathematics. It is about showing you that maths is not just about memorizing formulas and procedures for an exam. Instead, it is about creativity, innovation, and problem solving. And most importantly, believe it or not, mathematics can be enjoyable. You can have fun while developing strong mathematical skills. As you move around the Maths Fair today, you will see mathematics in action. You will see how it connects to science, technology, engineering, economics, and so many other disciplines. I encourage you to ask questions, try new things, and talk with our students and staff. They were once sitting where you are today, and many of them began their journey by attending events such as this. I also encourage you to check out the displays from other departments in the FST, all of which have exciting and innovative offerings. For us in the Faculty of Science and Technology, events like the UWI Maths Fair are extremely important. We believe that universities should not be closed spaces. We want to work closely with schools and teachers to support learning, spark curiosity, and help students see the many pathways mathematics and the other STEM areas can open. Please also look out for our SciFest 2026, which has now been moved to the first school term later this year. In addition, we are developing other initiatives for secondary school students. For example, one that is focused on strengthening research and innovation skills through mini research projects. Here we'll be bringing students within the campus, and they will be mentored and supported by UWI staff and postgraduate students. And you will have the opportunity to work in our laboratories to conduct research that address real-life challenges. In closing, I would like to thank Professor Rao Gunakala and the team in the Department of Life Sciences for organizing this event, which you will agree was a humongous task, given that we expect around 3,500 visitors today. Your energy, commitment, and passion truly make a difference. To the student present, this is your day. Explore, ask questions, have fun, and who knows, perhaps today will mark the beginning of your future in science, technology, or mathematics. Thank you and enjoy the Maths Fair.
Thank you, Professor Ramsubeh. Advanced graduate study and research in mathematics serves as the fundamental engine for innovation, providing the analytical framework and the abstract problem-solving tools necessary to decode and to model complex systems in everything from cryptography to global economic modeling. So on that note, please welcome to the stage Professor Duraisamy Saravana Kumar, Director of Graduate Studies and Research at the University of the West Indies, St. Augustine, to bring greetings.
Wow. This is so nice, and I'm so happy to see you. But I'm not a mathematician. So I had also asked the question in the 80s, because I'm a 80s kid, right? So when I was in secondary schools, I asked the question, what's the purpose of studying all these mathematical calculations, equations, algebra, trigonometrics, breaking my heads with sine theta, cos theta, so many formulas, but realized when I joined the university with an expansion of knowledge and in real life experience, how fused the mathematics is in all disciplines. For example, our actuarial science program within the Faculty of Science and Technology teaches our students how to use mathematics and mathematical probability to predict and to provide solutions for stabilizing regional financial sectors against global market volatility and natural disasters. In the Faculty of Engineering, our students use calculus and differential equations to understand the forces acting on physical structures. Researchers apply all these mathematical blueprints to design resilient bridges and coastal defenses that protect our islands from rising sea levels. In the faculties of Food and Agriculture and Medical Sciences, mathematical models are used for climate studies to predict the occurrence and spread of diseases in humans, animals, and plants. Professor Rao and his team has been working on mathematical models and its implications for delivery of drugs and magnetic hypothermia treatments. Similarly, the Faculty of Social Sciences Economics program employs statistics and metrics to create data-driven models necessary for evidence-based national policy. More than ever, now, artificial intelligence. Mathematics is the foundation for artificial intelligence. Originally, the word artificial intelligence was coined in 1955 by a lead scientist, John McCarthy, who is a mathematician. Then you can understand the power of mathematics. At this auspicious occasion, I would like to remind all of us and remember our own late Professor Emeritus, Harold Ramkissoon, who is a notable personality in the field of mathematics and his contributions to the country, region, and to the international platform. I am proud to say that recently we have launched the Artificial Intelligence Innovation Center at our campus, though we have been engaged in all of this work for many, many years, even before artificial general intelligence has become popular like now. Our researchers, especially youngsters, have been excelling in these fields. Dr. Leticia Edison, who is a mathematician, recently won COP29 Global AI Innovation Challenge that held in 2024 for an artificial intelligence-powered climate platform for small island developing states. Dr. Craig Romlall from the Faculty of Engineering has been recognized in 2023 as a global AI expert by the United Nations. In each of these domains, mathematics become the foundation upon which innovation, problem solving, and future leadership are built. In this way, the Math Fair stands as a true reflection of our commitment to enlighten young minds and shape futures. At the UWI St. Augustine, the idea of mathematics powering the future is realized every day in our academics program and research activities. Across our faculties, mathematics is applied as an engine of innovation and societal advancement. The UWI, with its research, has been listed in top 3.6% of global universities with the Times Higher Education ranking. Then you can understand the power of research and the power of work that the St. Augustine campus as well as the whole UWI is doing in this region. This year, the Math Fair is inspired by the theme, Island Innovators, Mathematics Powering the Future. With the growing interest among school children and teachers for this event, with the registration of over 3,500 students for this year Math Fair, I would like to interpret this theme as, today, mathematics is empowering the future of this country. To our visiting school students, I challenge you not to let the complexity of an equation intimidate you. Instead, see it as a puzzle. Once it is solved, it gives you the power to build a bridge. It gives you the confidence to build climate resilience community or lead a nation. Our region faces unique challenges such as climate change, food insecurity, economic shifts. We need your logical, mathematical minds to solve them. It is my hope that today's experience inspires you to one day join our campus so that you can gain the skills and tools to help you become future island innovators. I take this opportunity to inform that our application cycle for September intake is already open, and we look forward to your applications either to start your university program either in the coming academic year or the following years. Ladies and gentlemen, the vibrant event would not be possible without the organizers. I extend my sincere thanks to the sponsors and Department of Mathematics and Statistics led by Professor Rao and the Faculty of Science and Technology led by Dean Prof. Ramsibak for their leadership, meticulous planning, and for designing an engaging program of activities for today's Math Fair. Special thanks to our Ministry of Education for sending students for this Math Fair. Thank you, Dr. Smith, not only for supporting the Math Fair, but also supporting the postgraduate diploma in education, which helps to train the teachers across the country to advance learning and teaching methods. As I close, I wish to express my sincere appreciation to the secondary school teachers present today. Your unwavering commitment to guiding, mentoring, and inspiring young minds in mathematics is essential to build the capacity for innovation and leadership across the region. Please use some of these techniques or else the methods that you see here, and even develop more innovative experiential way of teaching not only mathematics but also other subjects. I invite all of you to fully engage with the activities of the day and explore the beautiful campus. May this fair spark curiosity and deepen your appreciation for the power of mathematics. May God bless everyone. Thank you.
Thank you, Professor Saravana Kumar. Continual collaboration and partnership between the Department of Mathematics and Statistics at the University of the West Indies and between the Ministry of Education is essential for the advancement of mathematics education because it synchronizes academic expertise with national policy to foster a mathematically literate society. And so I would like you to please welcome to the stage Dr. Peter Smith, the Chief Education Officer of the Ministry of Education.
permit me to stand on the protocols already established, but to certainly recognize our featured speaker, Dr. Filbert Morris. Yesterday was World Read Aloud Day, and I may have overdone it a bit in reading to our children. Good morning, everyone. Allow me to convey, on behalf of the Ministry of Education, my sincere appreciation for the UWI Math Fair, which serves as a platform to showcase the practical applications of mathematics, inspiring our students to see beyond the numbers and equations to understand its relevance and the world around them. From the start, we extend our sincere appreciation to our valued sponsors for their generous support and partnership. We acknowledge CIBC for its continued commitment to education and youth development, UNIPET for its investment in community advancement, Domino's for its consistent support of our schools, Optometrists Today for promoting student health and vision care, and of course Bermudez, a distinguished Caribbean brand with a long-standing tradition of corporate responsibility. Their contributions have been instrumental to the success of this initiative, and we are deeply grateful. William Arthur Ward said, and I quote, "Feeling gratitude and not expressing it is like wrapping a present and not giving it." I believe our sponsors as well as UWI deserves a round of applause. And so sometimes we attend these fairs and we may not realize the amount of effort in terms of human resource as well as finances that go into it. So we are really appreciative of this yearly initiative. Mathematics is the quiet engine behind almost everything shaping our future. You don't always see it, but you feel its power everywhere. We gather here under the theme, Island Innovators, Mathematics, Powering the Future. If I may hazard a guess, the theme suggests to me a process of integrating perhaps indigenous knowledge, systems, cultural practices, and local languages into mathematical education to make it more relevant, meaningful, and culturally responsive. It involves recognizing that mathematics is not culture-free, but rather deeply connected to cultural, social, and environmental contexts. Key approaches include perhaps using local materials for geometric concepts, storytelling to introduce numbers, and recognizing indigenous contributions to mathematics. The partnership between the University of the West Indies and our secondary schools provide a unique opportunity to address and overcome challenges and apprehensions that individuals may harbor towards the field of mathematics. And I don't know how many of us follow the news when CSEC results are released, but for our CAPE, that pass rate is over 95 on a yearly basis. For CSEC, however, CSEC mathematics, the pass rate is just hovering around a little under 50%. So we do have challenges that we need to address, yet it's that low in some instances. It is also in keeping with the ministry's and government's national strategic objectives of focusing on the student, along with two other critical pillars, that of the parent and the transformation of the education system. teaching mathematics using Bruner's enactive, iconic, and symbolic stages, often referred to as concrete, pictorial, and abstract, ensures students build deep understanding by moving from hands-on physical experiences to visual representations, and finally to abstract symbols. The truth is, very often we move straight to the abstract, and so many of our students are lost. And so as you engage in the activities outside, they may seem basic to you, but really they are the fundamental building blocks for mathematical knowledge. So please engage in the activities. So as you visit the booths, that is the principle that the University of the West Indies and our valued stakeholders are trying to instill or pass on to you. There is also the applicability of these mathematical concepts that you will learn. For example, quadratic equations facilitate the following: calculating the height, maximum height, and trajectory of objects like balls, missiles, rockets, even bullets; designing suspension bridges, cables, satellite dishes, arches, and automobile brakes; determining dimensions of spaces, such as finding the width of a walkway or frame around a garden where the total area is known; predicting the path of a golf ball or a basketball. So mathematics is all around us. Saying that math is the basis of life is much of an understatement. It helps us in comprehending the world with greater clarity. Without the risk of initiating any discipline or subject wars, mathematics educators are indispensable in fostering critical thinking, unlocking STEM career opportunities, and building essential life skills. They go beyond instruction to cultivate a growth mindset, helping students to overcome math anxiety. I wonder if we have anyone here who have ever experienced math anxiety. Do we have anyone? At one point, yes. Connect concepts to real-world applications and develop resilience. Their impact directly influences student achievement, confidence, and long-term career trajectories. Educators, secondary school teachers, professors, your role is extremely valuable. To the students, I encourage you to actively participate. Engage in the various activities and absorb the knowledge and skills being offered. To the educators, your dedication to shaping the minds of the future is truly commendable. And events like these amplify the impact of your efforts. As I close, let us embrace the spirit of exploration and the pursuit of knowledge as we embark on this exciting journey through the UWI Math Fair 2026. The Ministry of Education welcomes even more collaborative initiatives, and we definitely heard a couple today, such as these. I thank you, and may God bless us all.
Thank you very much, Dr. Smith. Today we are honored to welcome our featured speaker, Dr. Filbert Morris, who has lived at the intersection of abstract mathematical theory and practical reality. In academia, he served as a senior lecturer and also as head of the Department of Mathematics and Computer Science at the University of the West Indies, St. Augustine, which later became the present-day Department of Mathematics and Statistics. He was a dedicated lecturer, inspiring his students. I know because I was one of his teaching assistants way back too long ago, and Dr. Dial Singh, who is sitting here, was also one of his teaching assistants. He also served as the Vice Dean of the Faculty of Natural Science, which evolved into the present-day Faculty of Science and Technology. But Dr. Morris did not just teach mathematics, he also put it to work. While shaping young minds as a mathematics educator, he also served as the chairman of the Public Transport Service Commission, the PTSC. And in 1996, he took a bold leap, transitioning his expertise from the lecture halls to the business world. He left the university to lead his own software transportation consulting firm, using his knowledge of mathematics to solve the logistical challenges of the modern world. And so please join me in welcoming our featured speaker, who has indeed proven that mathematics is a pathway to unlimited horizons, Dr. Filbert Morris.
Good morning, all protocols observed. I want to challenge what people have said that mathematics is. And I want you to think about it in a slightly different way. Just think for a minute. And this is something that I did. I remember at one stage, I gave a course. I used to be teaching history of science and philosophy in the university when we had these courses. And I remember saying to some students, just think that you have to describe to somebody how to go from Tunapuna to San Fernando. And somebody tells you that what you do is, you know, you look for the doubles man with the red hat, and then as you pass there, you'll see some flowers by a door. And then you go down there and you pass so forth, and you pass by a green hedge, and if you go that, you'll see where there's an old taxi park up, and then, now if you do that, and think instead what you do. You can just, as we all do these days, use our maps on our car, or you can draw a simple diagram. You can forget the doubles vendor, you can forget the flowers, you can forget the hedge, and you can focus on what is there. You can do this. I don't know if you can see it here. In this first thing, you can just draw what is essentially a map. You go from this point to Napona here, and you could draw another thing there, and a line that. Just points and lines. And what you have done is that you have abstracted, because you have removed all that is important. You have removed anything that is not important. Now, it is this abstraction that is the important thing. And then, once you have abstracted, you will find that that same problem, that same abstract thing, just these points and lines, can be reapplied to a lot of different things. Because you can think of these points and lines as a pipeline. You can think of it as a road. If you have, in this first diagram here, you can put arrows in it. It may mean relationships among people. So the idea of mathematics is not so much as a problem-solving tool, but as an abstraction of removing all the garbage, removing the guy with the doubles man with the red hat, removing the hedge, and seeing what is essential. That is mathematics. And once you do that, you get something that you can then reapply to several different things. The lines and so on that represent the directions on the map, you can think of as, for example, a pipeline carrying gas. You can think of relationships between people. And the things that you think that you find out about this diagram just by looking at it, then come back and are useful to you. Here is, in that second diagram, the one at the bottom. There is an old puzzle that a man called Euler solved, called the Bridges of Königsberg, which I think you may come across there, where people on a Sunday in a town in old Prussia, in Königsberg, there were these bridges, and people had fun walking across these bridges and then deciding whether you could walk over the bridge once without crossing back in the same bridge at all. In other words, whether you could do the whole walk and visit each of the points without using any bridge twice. If you do it by standing up and walking around with the bush around you and the trees and all the rest of it, it's difficult. But if you sit down and you draw a diagram, you see immediately something that famous mathematician Euler saw, and that is very simple. If you have to go in and never come to a place twice, it means that if you go in, then you must be able to come out. And therefore, if you look at this diagram, if you have any point which has an odd number of places where it meets, then it can't be done. Think of that, because if you go in, you must be able to come out. Simple. And if you come back to that point, if you go in again, you must be able to come out. So 1, 2, so it must be either 2, 4, 6, 8, or whatever. But if you have any point with 3 things, and Euler sitting there, therefore, without walking around in a bush, without going in the snow or whatever else, solved the problem. And that is what you're looking for. It is not so much to think of mathematics as a tool in itself, but to think of using mathematics to look at problems in a way in which you abstract, you simplify, and you see the problem, nothing else. You focus on the problem. And that is the strength of mathematics. We can give it all names. We can see different approaches, different things. We can look at it, for example, we can see different applications. We can see, for example, that some of us deal with looking at waves and how the waves are, waves at sea, waves in the tank. And then you just think of waves themselves, and you can get a lot of information and a lot of ideas and see what is there. And then, having done that, you can approach different things in different ways. Now, I have done this for quite some time, and I've found it a very successful approach. I've given talks. When I was on campus, I would go to schools and pester some of you. Well, none of you here now would know about that. This would be quite some time ago. And point out, give short talks to students, and they would come back and they would ask me questions about what I've said. And I've been able also, by being part of the examining things on CXC, to see how students think. And this is the way that I would want you to think, not by thinking of mathematics as a set of formulae to be learned, not by thinking of mathematics as essentially as a thing in itself that you have to be afraid of, but of mathematics essentially as a language of abstraction and simplification that you can then apply to anything. Because it's literally anything. Anything that you can think about can be stripped of all the extraneous things that confuse the issues. And once you approach things in this way, mathematics becomes much more meaningful and much, much more accessible to you. Can you tell me how I could move the screen to the next? Okay. Okay, right, thanks. Okay, come on, do that. No. Okay. Now, when you do that, however, you can still have fun with mathematics itself. And that's why you can come back and let's take a look at a diagram which comes out of the same simple problem of drawing something like a map. Here is, on the first one, you see what we call, in the subject in which I work, graph theory. You see something that we call a graph. And there are lines, and then we have these little circles, so that you have the things where the little circles that I label 6 and 2 and 3 and 4 and so on. And when one interpretation, you may think of those as places, and the lines as roads joining them, or whatever it is. But you can convert this into a neat little puzzle. And a little puzzle is, suppose you put numbers on all of the places, as you can see that I have labeled 1, 6, and 1, and 5, and 2, and 4, and 3. And you can ask yourself, well, okay, let's look at the first line, 6 joined to 1. In other words, there's a bar between 6 and 1, that one up there. And the difference between them is 5, and I've circled that. And then there's 1 to 4, and 1 minus, the difference between 1 and 4 is 3. And there is a problem which was given to me when I was doing my PhD. I remember that the man who thought of this problem came up, was there with my professor, and he mentioned this. I pointed out something immediately to him, and he was surprised at it. But that problem, and I'll tell you what the problem is, has remained unsolved since then It's been unsolved for nearly 90 years. The problem is this. Suppose you have a diagram like this, which we call a graph. Can you always move about the numbers on the nodes, as we call them, that's the circles, the 6, 1, 2, 3, 4, 5. Maybe you can put the 4 where the 2 is and the 3 where the 2 is and so on, so that when you look at the differences between the 6 and the 1 and the 5, the differences are all different. Now, to do that, nobody in the world has been able to figure out a way of solving that problem. It's called the graceful graph problem, and it's been a challenge for so many years. And it says something about mathematics. It says that I call this particular problem an insulting problem. And the reason why I call it an insulting problem is that somebody can come up to you and say, but you fellas have all this maths thing and differential equations and things, you can't solve that. That's easy to see. No. I challenge you to try it yourself. You will see that there are some figures, like that one here, in which you can simply, if you see what the trick is, you want to label all of these from 1 to 7, and what you do is you put 1 and skip 1, and you put 2, and you skip the 2, and you put 3, and you skip the 3 and the 4, and then you come back down. And if you look, 1 minus 7 is 6, 7 minus 2 is 5, and so on. So if you have a straight line, this is what we call this thing a graph. If you have a straight line graph, you have no problem. There's a way to do it. And obviously, if you have something like a star with just one point in the middle and everything else radiates from that, then you can see that it's very simple to do. You put a 1 in the middle and you put the others. But if you have any graph at all, can you do it? And that says something, because that problem still challenges me from, I won't tell you how long ago. And it remains an unsolved problem. Nobody in the world has been able to say that you can always do this for any graph. Some of you may think that, well, we can use a computer and try and do it. Yeah, but when you draw these diagrams, these trees, they multiply enormously. And if you take a computer, we have done it up to 35 nodes. If you do that, nodes are points there. If you do that, that's up to 35, so what about 36? And then if you do it up to count all 36. So the idea of doing all is an entirely different problem. Now, why is this? Why do I show you this problem? What I show you is that you can think of mathematics in several ways. You can think of mathematics having faced a problem and abstracted and found something. You can begin to enjoy, and the word is enjoy because tackling problems is enjoyable to some people like me. You can enjoy just looking at the problem itself and fighting along with it. And this is not necessarily an application. This is pure mathematics. You're not interested in what it can do, whether it can apply, but it comes from real life. And this is the way things work. You have things in real life. To be able to think of them clearly and cleanly, you abstract. You then can look at the abstract things and play with them and come up with different things. You can really apply these things to different objects, different problems, different times. This is the application of mathematics. And then there's pure mathematics, where you just look at the problem itself and come up with things which may or may not be useful. Now, I don't know about you, but I have found, in my own time, I found it very interesting to stay in mathematics, to look at mathematical things, and also to apply these mathematical objects to what I essentially spend a lot of time doing, and that is transportation. Let me just, by the way, ask you a question. Do you know what this is? Take a minute or two and ask yourself what that is. Let me tell you what it is. That is 25 cars. That is one maxi taxi. And that is a problem we have in Trinidad and Tobago that keeps me awake at night when I'm not doing pure mathematics. There's a theorem in transport theory that says that if you build more roads, you get more traffic. And what is happening to us, well, I don't need to describe it to you. Trinidad has gone way beyond. We have in transportation, to which I've applied a lot of things, we find that we really have problems. One of them is that we have a bus route that we don't use. For many years, let me just digress and give you a little story. I was at a conference, a transport conference in England at one stage, and they were talking about how they had put a bus route in Curitiba in Brazil. And that was 16 kilometers. And I got up and said, well, ladies and gentlemen, we have the world's longest bus route. That was before the Americans built one a mile longer in Florida. And ours is 16 miles long. And we don't use it for what it is. And why is and we don't use it because the Queen doesn't drive a train. And everybody looked at me, what a madman is this he's talking? And I said, well, what happens is that you see the president goes on the bus route, and then the deputy president, and then the vice president, and then the prime minister, and so on. And it becomes a big boy route. But these problems, if you look at them, they may seem to you to have nothing to do with the lines and the little graphs that I've talked about, but they are. And the way that the things that I have been working on, for example, when I've done things at PTSC and other things, apply these things in transport and so on, have come not from actually doing anything grand, but looking at this problem, abstracting it, in other words, mathematicating it, boiling it down, looking at what is essential, and coming to grips with it. And this is what I want you to think about as you leave here. I want you to think that not only roads and lines, things like waves, when you look at, there are people who look at hydrodynamics and look at waves and things like that. I want you to think of mathematics not as a frightening thing in itself, but as a way, a language, a way of looking at things, a way of abstracting. And in that method of abstraction, you may come to like just looking and playing with the object itself. That is the problem that I showed you. And this is what, in a sense, intrigues me. I have spent a lot of time playing with the pure problem and getting nowhere. And I have spent a lot of time here and sometimes over in helping in engineering, looking at these problems and also getting nowhere. But these are the problems that you can attack in both the same way. And mathematics is a tool that joins these two, and mathematics is a thought process that I want you to have in looking at problems, thinking about them as an approach. You look at things, and what you do is always remember to forget the doubles man in the red hat. Thank you.
Thank you very much, Dr. Morris. So we will now have two special presentations to two people who have made significant contributions to mathematics education. The first is to Dr. Charles DeMatteis. He is an academic whose journey began in engineering and then proceeded to advanced degrees in mathematics from the University of Pittsburgh and the University of the West Indies, St. Augustine. From 1996 until his retirement in 2025, Dr. DeMatteis was a cornerstone of the Department of Mathematics and Statistics here at the University of the West Indies, St. Augustine. But even in retirement, his passion for discovery remains undiminished. Today, he continues to work on the method of Stroop's, which connects two branches of engineering, structural analysis and electrical circuit theory, and he shares his insights with the world on his YouTube channel. And so, for his significant contributions as a dedicated lecturer in the Department of Mathematics and Statistics at the University of the West Indies, we are proud to present an award of appreciation to Dr. Charles DeMatteis. I would like to invite our head of department, Professor Sridhara Rao Gunakala, to the stage to present the award to Dr. Charles DeMatteis, who I would also like to invite to the stage. We'd like to ask Professor Rao to remain on the stage. The second award is to Dr. Indra Haraksingh, who emerged from the Department of Physics at the University of the West Indies, St. Augustine, as a global leader in renewable energy. She pioneered the region's first master's program in the field, and she has been recognized on the world stage from Germany to Portugal with prestigious honors, including the Life Pioneer Award from the World Renewable Energy Network, For her service to our nation of Trinidad and Tobago, she was awarded the Hummingbird Medal Silver for loyal and devoted service to Trinidad and Tobago in the sphere of education. For over 30 years, Dr. Haraksing was the heartbeat of the Trinidad and Tobago Mathematics Olympiad for secondary schools. This was an initiative of our Department of Mathematics, yes, but she served as the chair and coordinator for many years, and she has cultivated a culture of excellence. Since 1995, she has personally guided our national teams of secondary school students across the globe to the International Mathematics Olympiad, an international mathematics competition. I myself have seen her here on Saturdays, given up of her time to coach and to mentor young high school students to prepare them for this demanding competition. And so for her 3 decades of unwavering commitment to our young mathematicians, we are honored to present this award to Dr. Indra Haraksing, who I will now invite to the stage. Thank you, Professor Rao, and congratulations and warm wishes to Dr. DeMattis and Dr. Haraksing. This event would not have been possible without the hard work and valuable contributions of many people, some who labor tirelessly without asking for and without expecting any thanks. But he who is not thankful to the people is not thankful to the Creator. And so we will have a vote of thanks by a particular speaker who in fact should be the one receiving thanks, because he has been the chief coordinator of this math fair and previous math fairs, and anyone who has been involved in these fairs knows exactly how hard he works and how dedicated he is. And so I would like to invite to the stage Dr. Akenatan Daga, the lecturer in the Department of Mathematics and Statistics, to deliver a vote of thanks.
All protocols observed. It is a great honor and privilege for us to stand here today and express our sincere thanks to those who have made this event possible. Firstly, I would like to thank and express my gratitude to the Almighty for bringing all of us here to get together here today safely and without incident. I would also like to give a heartfelt gratitude to the Master of Ceremony, Mr. Asad Mohammed, for his excellent coordination and flawless engagement with you all today. Please give him a round of applause. We wish to thank the Ministry of Education because they have supported us for so many years. Without their granting the approval for you to attend here today, it would not be possible. Please give the Ministry of Education a round of applause, as well as your teachers and parents who have brought you out today as well. We'd also like to thank the Office of the Dean of the Faculty of Science and Technology. The Dean's Office has been instrumental from the inception of this program. Thank you to all of our speakers today. From the Chief Education Officer of the Ministry of Education, Dr. Peter Smith, Director of Graduate Studies and Research, Professor Durisamy Sarvanakumar, the Dean of the Faculty of Science and Technology, Professor Ida Shamsubag, to the Head of Department, Professor Sridhara Rao Gunakala, and our featured speaker, Dr. Filbert Morris. Thank you all. Please give them all a round of applause. I would also like to thank the hard-working members of our Department of Mathematics and Statistics, who have contributed tirelessly to what is the success of today's event. Our Administrative Assistant, Ms. Dolores Adams Carrington, Our secretary, Ms. Nisha Hazelwood. Our clerical assistants, Mr. Jason Chamaru, Mr. Isaiah Williams, and Ms. Erlyn Williams. Our math poster coordinator and former coordinator of previous math fairs as well, Dr. Alana Sanka. Our math creativity coordinator, Ms. Abby Sonwan. Our statistics poster team, Dr. Isaac Dialsing, I've seen him in the crowd here, and Ms. Whitney Ramjatan, who's busy at work at the JFK Lecture Theatre. We'd also like to thank the organizers of the math field competition, Ms. Devika Bagwandid, over there, and Mr. Vikash Ramcharata and Ms. Adriana Ragbir. Our full-time demonstrators, Mr. Sherman Harris, Mr. Jordan Ramai, Mr. Adam Joseph, and Ms. Shinisa Graham. Our live stream moderator, Mr. Kieran Dianan, up there in the control room, and of course, all of our committed lecturers from the Department of Maths and Statistics. Thank you to our sibling faculties and departments for their participation in the event, to Mr. Sanya James and Darren Granger from the FSD Media, of the FSD Dean's Office Media. Thank you for your continued support with the Math Fair. I'd also like to extend our heartfelt thanks to the Alma Jordan Library staff and for their providing us with the library tours and for invaluable resource and support during this event. I would like to express our sincere gratitude to our registration and logistics teams. We had our exceptional lead volunteer coordinator, Mr. Rajesh Lakan, whose hard work and dedication managed over 300 volunteers that you're seeing all throughout this event. Please give all of them a round of applause. To Mr. Jagdish Ramnanan, who made tireless efforts to optimizing and assigning the duties of the volunteers, and to Mr. Salim Kamaluddin, who readily served as our secondary school liaison, ensuring that all our attendees were welcomed and were very brought in here smoothly. I'd also like to thank Dr. Dale Jogi for also being on that liaison committee. Thank you for the USH team and the Campus Security Services for their commitment to ensuring that we have this safety in our attendance today, to the marketing and communications team, including Ms. Josanne Green, and to Noob Nation. When you go into the JFK Auditorium, for the first time, we will be having esports games, mathematical computer games, on computers over there. Some of you all may get to play it. And my sincerest gratitude to the sponsors. We extend our gratitude to our sponsors from Unipet, who have been with us for so many years and served so much. CIBC Caribbean, Optometrist Today, Domino's Pizza, and Bermudas. Please give each one of them a round of applause. The sponsors are so important to what we are doing here today. Many of you out of this crowd here, someone here is going to be the organizer of a major event like this. And I'm telling you, without your sponsors and without these tireless workers, you cannot pull off these events, right? And we want to give our sincerest gratitude to the volunteers, those who are ushers, our tour guides, our game specialists. We couldn't have pulled this off without you, without your remarkable contribution, all our undergrad students from all the different departments and faculties. And lastly, I would like to also extend my heartfelt thanks to all of our wonderful audience for being here today, all the schools, principals, teachers, and students. Your presence, attention, and enthusiasm for this live event has been so much appreciated. Thank you all.
And so that brings us to the end of this opening function. We'll have a 15-minute break, and then the math feud competition would start. But before you leave, we'd like to ask all the speakers and the awardees, Dr. Haraksing and Dr. DeMatteis, to please come on stage for a group photograph. Yes, correct? And I bid you a good morning, and please enjoy yourself and enjoy the activities for the rest of the day. Good morning to you all. Thank you very much for your attention.
departing from platform 3. Passengers with tickets for this service, please proceed to board now.
testing 1, 2.
Yeah.
Testing 1, 2.
Okay, ladies and gentlemen, welcome to the 2026 UWI Math Fair Math Feud. I'm your host, Kiran Dayanan, and what we're doing here today is our rendition of Family Feud, right? But instead of their types of questions, we'll be asking you math questions. So the format is simple. What we did over the last month, we held our math quiz, and we took the top 2 winners of each of our categories, and we have them here today to compete head-to-head. Right? So the rules are simple. There will be 2 rounds, and hello. Right. And each round, we will start with the junior of the team, then we'll move to the junior of the opposing team, the intermediate, opposing intermediate, senior, senior, right? So just to remind you all, each question, whoever is answering, you will have a maximum of 30 seconds to answer the question. And if you get it right, you will get 10 points for your team. If you get it wrong, however, the respective person on the opposing team could steal. Stealers, if you have to answer a question, you must answer immediately, right? So if you get a question correct, you're going to hear this sound. And if you get a question wrong, you will hear. So just a side note, there are 2 penalties. If you answer out of turn, that will be minus 2 points for your team. And if you, even though it's a team game, we want all the answers to be individual, right? So if you all communicate during the event, that's also a penalty of 2 points, right? Okay, so today here we have, keeping time and score check, Mr. Vikash Ramcharitar and Ms. Devika Bagwandin. And we have my co-host.
My name is Adriana Ragver.
Cool. So you all ready? Okay, so if we could just start with the junior on this side. Introduce yourself, tell us which school you're from, and we'll make our way around the table.
My name is Risha Rupchan. I am from Holy Faith Camp, Vancouver.
The intermediates.
My name is Omari Bernard, and I'm from Naparima College.
Hi, my name is Serena Dukaran, and I'm from Parvati Girls Hindu College.
Hi, my name is Zimriana Baban, and I'm from St. Joseph's Convent, San Fernando.
My name is Michael, and I'm from CSU Secondary.
And my name is Rashnad Mohammed, and I'm from Naparima College.
Okay, lovely. So, on this side, these 3 guys, their team name is the Pythons. And these 3 guys over here, they are the Limit Breakers. Okay, so without further ado, the math feud.
Okay, so we do have the junior question 1 going to Risha. So we have the question 1, the topic is angles. So the question is, find angle X in the diagram below.
$35.
All right, that is correct. So we go on to question 2 now. Question 2 is angles as well. So find angle x.
210 degrees.
All right, so we on to the intermediate questions. So question 1 goes to Omari. Topic is ratios. So we have sum of 3,500 is divided among Alex, Jade, and Tony in the ratio 2 to 2 to 3. How much did Tony receive?
$1,500.
Alright, question 2, same topic of ratios. This question goes to Michael. So your question is, a sum of money was divided between Adam, Crystal, Frank, and Josh in the ratio 1 to 3 to 2 to 2. If Adam received $250, find the sum of money that was shared.
$2,000.
Alright, we have the senior round now. So we have the topic of differentiation. So this first question goes to Serena. So find dy dx of y equals 2x minus 3 into x minus 1.
X minus 2.
Okay, so Reginald has the chance to steal.
4x minus 5.
Alright, so question 2 is to Reginald. So find dy dx of y is 2 over x minus 5 all squared.
Minus 4 over x minus 5 cubed.
Right, so this is the end of round 1. We go on to round 2. So
just
okay.
a quick reminder, audience, I noticed some of you all are clapping before the answer, which is great. I guess we have a lot of mathematicians here. However, try not to disturb or distract the contestants, right? We don't want anyone shouting out any answers or talking too loud, okay?
Okay, so round 2, question 1 goes to Zimriana. So again, well, we have junior question 1, goes to Zimriana. Topic is decimals. Okay, so Risha has a chance to steal. And so the answer is 0.725. So we go on to question 2. Question 2 goes to Richa. So we expressing the value of 2 over 8 plus a half plus 11% as a decimal. Okay, so that question was for Risha. Zimriana can steal.
0.125.
Okay, so we have the answer as 0.86. Alright, we go on to the intermediate questions. So question 1, well, the topic is algebra. Question 1 will go to Michael. So using the equations below, we want to find the value of x. 5x plus 4y is 2, and 9x plus 8y is equal to 10.
$0.5.
Okay, so Omari can steal. Okay, so we have the answer as x equal minus 6. Alright, so we're going on to intermediate question 2. Topic is algebra again. So this question 2 will go to Omari. If x plus 2y is 3 and x minus 2y is minus 1, what is the value of y?
One.
Okay, it's correct. Okay, so we go on to the senior questions. So the topic is logarithms. So question 1 goes to Reginald. So we want to reduce the following expression, log of 9 to base 2 multiplied by log of 4 to base 3.
Four.
So question 2, same topic, logarithms. This question will go to Serena. We want to evaluate the following. So log of 1/5 to base 10 plus log of 5/7 to base 10 plus log of 7 over 10 to base 10.
One over 10.
Minus 1.
Alright, so if we could have a, alright, so at the end of round 2, if we could get a tally of the points.
So as our judges tally the points, these guys, they worked really hard to get here. The math quiz I spoke about earlier, there were over 200 participants in that quiz, which means these were the top 2 out of 200 people. Okay, the results are in. Audience, could I get a drum roll, please? Okay. Our winners of the our winners of the 2026 Math Feud, the Limit Breakers. So the Limit Breakers won with a total of 50 points, and the Pythons came second with a total of 30 points. So at this point, what we would like to do, after we present the trophy to our winners, the parents of any of the participants on the stage, if you all would like to come down and take a picture with your kids, you could do so after we present the winners.
Good morning, everyone. We'd like to invite Dr. Insamam Rahman to join us to present the second place winners with their trophies.
Okay, guys, so after we present the trophies and the parents who want to take the pictures, we're going to have some career talks by a panel of esteemed persons. You all are welcome to stay for that and maybe look at what you might be doing with mathematics in your future if you choose to do so.
Okay, so calling out the second place team for juniors, we have Risha Rupchan from Holy Faith Convent, Vancouver. All right, we have Omari Bernard from Naparima College. And we have Serena Dukaran from Parvati Girls Hindu College. All right, we thank Dr. Inzamam Rahman for giving out these trophies. We want to call on Dr. Dale Jogi now to give out the trophies for the first place winners. So for the junior, we have Zimriana Baraban from St. Joseph Convent, San Fernando. We have for the intermediate, Michael Mohammed from Caribbean Union College. And for the seniors, we have Reginald Mohammed from Naparima College. All right, so we thank Dr. Dale Jogi for giving out these trophies. If any of the parents want to come and take pictures with the children now, you can. Or not.
Parents, you could feel free to come on the stage with your child if you would like.
This is a final boarding call for the train to San Fernando, departing from platform 3. Passengers with tickets for this service, please proceed to board.
you last. Yeah. I'll just. Okay, okay. Okay, guys. So, to close off the proceedings here at Engineering Lecture Theatre, we want to get into the career talks for this afternoon, right? So, what this is basically going to be, we're going to have our guest speakers come up and they're going to discuss, you know, the professions, the job roles, their career paths, and hopefully inspire some of you all to follow in their footsteps. So our first speaker for this evening is our department's very own Mr. Stokely Smart, and he's going to talk about the anythingness of algorithms. So please welcome Mr. Stokely Smart.
Let's do this. Sarah. How do I get this in? Reading? No, wait. Oh, reading. There we go. Yeah? Oh, so hi. Good morning. Welcome. My name is Stokely Smart, and I am the director of the Actuarial Science program here at the University of the West Indies, St. Augustine. The program has been in existence since 2011. And I'm here to discuss a bit about the, the word algorithm has come into a certain amount of notoriety of late in just generally, of course, with the advent of smartphones and whatnot. So I'm to come to give a bit of a anythingness in terms of the application. So, what is in the real world of an algorithm? So, for something to be considered, three important of instructions, so that well defined and not ambiguous. Where did the term come from? Where did the word algorithm originate from? So, it can be traced back to the 9th century AD to a Persian astronomer and mathematician named Abdullah Muhammad bin Musa al-Khwarizmi. That's right. And he. So examples of this ratio where it occurs in nature include flower petals, in particular sunflower petals. Where they will occur in numbers that exactly match the Fibonacci sequence. Also in faces, it measures for beauty across ethnicities and all these other things, and they found that faces that most closely met had a golden ratio inbuilt into them, and you could do this face also afterwards. The ratio is actually built into the geometry of human faces. in fruits and vegetables, in particular pineapples, in terms of how the sort of pegs on the surface of a pineapple. Again, you find examples of that sequence, and generally in any sort of spiraling pattern. So in particular, the shell of the Nautilus, the Nautilus, which is a sea creature, has something called the logarithmic spiral, which, and our inner ear, which has that shape as well, and the ratio against permeates the design of those things as well. As it's also found in spiral galaxies, like our own, the Milky Way, and our closest neighbor, the Andromeda galaxy, as well as in, if you look at a hurricane, that shape, the logarithmic spiral is there as well. So examples in nature where, the algorithm abounds. All right. So, what are the applications of these algorithms in the modern world? And they are varied and many, and they impact all of our lives every day, almost all day now. And of course, examples, in the application of actuarial science abounds with algorithms in your smartphones, which I'm sure everyone here has, right? And the algorithms that power some of the apps within them, and even in the hardware. Of course, AI is run by algorithms, search engines, etc., musical compositions, weather forecasting, meteorology, architecture, as we demonstrated earlier, space exploration, and there's quite a few. And I said earlier, I'll give an example, a real world, an example that, as a human we can use to demonstrate, the application of an algorithm having the three characteristics. So I use an example of an algorithm for increasing the probability for folks here when they enter the working world for getting employed. So, step one, get a 1 or 2 in CSEC mathematics and additional mathematics plus 3 other subjects, including English. Step 2, get a 1 or 2 in K-pure mathematics and applied mathematics. Step 3, get accepted to, apply and get accepted, having gotten those grades, to the BSc in Natural Science at the University of the West Indies, here at St. Augustine. Step 4, complete the program. And the data will indicate that having completed these steps, gone through that algorithm, you can demonstrate some data that demonstrates for statistics for graduates where folks that have graduated from our program here in actuarial science at St. Augustine have been employed. So to date we have about 258 graduates since inception of the program. So our first cohort would have been 2014. 258 graduates. We have 35% in traditional employment roles. So these would include things like at insurance companies and actuarial consulting firms. 42% in non-traditional employment positions. 9% in postgraduate programs, so doing their masters or PhDs. About 8% unemployed, and then I have 6% we don't have any data on. So that's not too bad, and salaries seem to be going up, especially after COVID for our graduates, because COVID demonstrated that folks with our degree have the ability to work pretty much anywhere in the world because of the algorithms that run Zoom and such. Right. So here are some of the employers of graduates from the BSc in Actuarial Science. And so our graduates work in about 8 different countries and are employed by about 70 different institutions and counting. So you have to put it on 2 different, so there's a grid. Anyone interested in this, I can supply this to you afterwards. So wide variety of employers that folks with our degree have. So again, if you follow the algorithm that I indicated a few slides back, and here are some of the institutions that you can find gainful employment at. So that's one slide here, everywhere from UWI to the Bank of America, Kent University, Extra Foods, CL Financial, Massey Technologies, just goes on and on. Here's another slide here. There's so many of them. So yeah, it's about 70 or so we have and counting. Hadco, Prestige Holdings, Agustin Insurance, Gulf Insurance, even a chocolate manufacturer, etc., etc. Okay, and that's all I've got for you on algorithms. Thanks for your attention, and yeah, and thanks for being here. Thank you very much.
Thank you, Mr. Smart. Just by the way, that seems to have been the official advertisement for the Department of Mathematics and Statistics, so maybe that's the department you all should apply to at UWI. Okay, our next speaker is no stranger to the Math Fair stage, speaking about your SBA, the first innovation project. Please welcome Dr. Dale Jogi.
Aha. So, according to Mr. Smart, there's an algorithm to get employed there, Mr. Smart? To get employed, there's an algorithm. So I believe step one of the algorithm was pass CSEC math, wasn't it? 1 or 2. All right, so this isn't necessarily a career talk, it's a real talk. And the SBA is real. So, let me ask a question with a show of hands. Who here is currently doing an SBA or has one coming up soon? Now, keep your hand up if you're excited about it. That's so honest. I like you. All right, who here sees the SBA as something you just want to finish, submit, and never think about again? You guys are so honest. You guys are seeing it as busy work. You know what is busy work? An activity that is undertaken to pass time and stay busy, but in and of itself, you believe it has little or no actual value. Who thinks that the SBA is busy work? Okay, be honest. Your SBA is not busy work. It's your first innovation project. So let me talk about the 3 domains of learning. Cognitive, that is intellectual skills. Affective, feeling, values, and attitudes. And psychomotor, coordination skills. Within the cognitive arena, there's 6 domains, there's 6 levels of learning. So there's a pyramid. Starts from knowledge, going up to creativity. Aha. So here we're looking at Bloom's taxonomy. So this gives the 6 levels of learning within the cognitive arena. Now, who's familiar with a distinction in math? There's something called profiles. Who's aware of that? How many profiles does math have? It's called K. Anybody know what K stands for? Knowledge. What is C? Comprehension. And what is R? So that's actually extracted. Knowledge is the lowest level of cognitive thought that's needed to get a mark. And you have to go up the ladder and think outside the box. So the highest level now is creativity. Let's think about what innovators do. They ask a question, yes? So if I were to ask you guys a question, what is the height of this room? Now let's think for a few seconds how you could find out the height of this room. Anybody want to volunteer how they would do it? Let's get an algorithm. Now you have some knowledge that's very low level. We could probably take a tape and measure the height of each threading and multiply the amount of threading that there is. Yes? But in terms of your SBA, does that show creativity? What about trigonometry? What about trigonometry? Could we use that? Could we assume that we have a right angle triangle and we need to get the height of the wall? That's the opposite side. And I'm sure we could figure out the width of the room. And use a clinometer and estimate the angle of elevation. Take tan of that, multiply by the width of the room, and there you have it. You have the height. Now, isn't that creative? It is, isn't it? But you have to think. You have to think outside the box. So you have to collect your information, you get the width of the room, you analyze some patterns and so forth, and then you make your decisions. So in other words, what they want to reinforce here is critical thinking. That is the real purpose of the SBA, you know. So let's go back to Bloom. So we have memory, understanding, application, analysis, evaluation, and what's the last one? Innovation. Creativity. Do we have real creators here? Do we have island innovators? The pyramid suggests that creativity, which is located in the small top triangle of that pyramid, is not only higher in terms of cognitive ability, but less frequently integrated into coursework than fundamental or foundational learning. So it's not as simple as doing BODMAS, 1 + 2 × 3. What is the focus of the SBA? How creative are we? Bloom's taxonomy is basically a ladder of thinking. So as you go up in the pyramid, the deeper is the thought. The higher you go, the deeper the thinking. Let's look at the lower levels, rungs 1 and 2, memory and understanding. This is where we have definitions, formulas, and worked examples. So anybody can memorize SOHCAHTOA. That's just memory. That's at the lower rung. But were we creative? Could we have used SOHCAHTOA now to get the height of the room? Most traditional exams test heavily in the lower rungs of the ladder. Middle levels, application analysis. This is where SBAs start to matter. In SBA, students do what? They choose variables. You apply formulas or formulae to your own data. You look for trends, and you compare results. That's analysis. That's not rote or memorization. The upper levels, evaluation and creativity, judgment and creation. In a well-done SBA, especially at the Form 6 level, students judge whether results make sense. You justify conclusions. You reflect on limitations. And you propose improvements and extensions. That is evaluation and creation and creativity and innovation. That is at the top of Bloom's taxonomy. Innovation does not live at the bottom of Bloom's. Think about what innovators do. They ask questions, they collect information, they analyze patterns, and they make decisions based on evidence. No guesswork. The SBA was designed with innovation in mind. Imagine if your SBA asks real questions like, why do taxi fares change depending on the time and location? I'll ever try to get a taxi in the night, 1 in the morning. Subject to availability, isn't it? The price will hike. How does rainfall affect flooding in my community? How do food prices change across different parts of this country? What constitutes an appropriate blood alcohol concentration threshold for impaired driving? Could collect some serious data on that. These are real problems. And mathematics gives you the power to investigate them properly. Mathematics turns opinions into evidence. Innovation is embedded in the design and purpose of the SBA. Your first innovation project. So some concluding remarks, some words to carry home. Move beyond imitation. Create something meaningful. Let curiosity, not convenience, guide the SBA. It's not something to just get done. Be curious. Use the tools that you have and be creative. Be an island innovator. Analyze patterns, not just numbers. Synthesize data into understanding. Interpret results with purpose. Justify conclusions with reasoning. Turn observations into explanations. Create solutions, not summaries. Innovation begins with a question worth asking. Mathematics becomes powerful when you use it to explore. Your ideas matter. Give them structure, data, and meaning. Think boldly, analyze carefully, conclude confidently. That's how problem solvers and island innovators are formed. Thank you.
Thank you, Dr. Jogi, for that passionate presentation. So, I would now like to invite one of our longest-standing sponsors for the UWI Math Fair. Please welcome to the stage our UNIPET representative, Ms. Liana Ali.
So for those who remain, it's still morning, so good morning. Of course, this speech will be light, it's not going to be as technical, no formulas. First of all, though, we want to begin by extending warm greetings to the distinguished officials and the special guests we had. We want to acknowledge Professor Adesh Ramsubag, Dean of the Faculty of Science and Technology, Dr. Shireen Hack, Deputy Dean of Outreach, and Professor Sridhar Gunakala, Head of the Department of the Mathematics and Statistics Department. We also recognize Professor Saravana Kuno, Professor Derek Chady, Deputy Principal, as well as Dr. Peter Smith of Ministry of Education. We also wanted to extend greetings to the leadership and the faculty of the University of the West Indies, members of our organizing committee, our partners, and of course, sponsors. And the educators who continue to shape young minds through their dedication to teaching and mentorship. A special welcome as well to the students joining us here today. Your presence is the reason the Math Fair exists. Whether you are here to compete or to explore, or simply because you're curious, we are glad that you are all a part of today's proceedings. It is a pleasure to be here at the UWI Math Fair and to stand in a space where curiosity, rigor, and possibility all intersect. On behalf of UNIPET, I'd like to thank the organizers, the faculty, and the University of the West Indies for creating a platform that elevates mathematics beyond the classroom and into lived experiences. Now, when we talk energy, we often default to fuel, electricity, or even motion. But at its core, energy is about transformation. It's about converting potential into action. And that idea sits at the heart of mathematics. Now, math is the language that allows ideas to move from theory into practice. It is how abstraction becomes application. It is how we take complex realities and we make them understandable, measurable, and improvable. Every discipline represented here today relies on mathematical thinking, engineering, economics, climate science, medicine, data analytics, and energy systems. They all depend on the same foundational skills: logical reasoning, pattern recognition, modeling, precision, the ability to question assumptions and to test outcomes before decisions are made. At UNIPET, we operate in the energy sector, but we are keenly aware that the future of energy will not be shaped by fuel alone. It will be shaped by people who think critically, analyze systems, manage uncertainty, and solve problems that are still emerging. Those capabilities begin here. For the students, especially those still deciding what direction to take, math is not about being perfect or getting every answer right. It is about learning how to think. It rewards curiosity, persistence, and the courage to stay with a problem a little longer than comfortable with. Math teaches you how to approach complexity without fear, how to break large challenges into manageable paths, and how to trust your reasoning even when the solution is not immediately obvious. Those skills stay with you long after the formulas are forgotten. This math fair is not simply about solving equations or winning challenges. It is about helping students to see themselves as the future contributors of innovation, sustainability, and national development. The same reasoning used to work through a problem on paper is the reasoning used to forecast demand, optimize logistics, assess risk, and design systems that are resilient and efficient. For the educators and the professors in the room, your role is central to this process. You are not only teaching content, but you guys are shaping confidence. You are helping students understand that mathematics is not a barrier to overcome, but it's a tool to be mastered and applied. UNIPED's presence here today is intentional. We believe that supporting education, particularly in analytical and STEM disciplines, is one of the most meaningful investments we can make. Not because every student here will work in energy, but because every sector benefits from minds trained to think mathematically and to act thoughtfully. As students move through the fair today, engaging with booths, challenges, and conversations, we hope they leave with one clear message. Mathematics is not about passing exams. It's about powering decisions. It is about fueling innovation, and it is about shaping the future. Thank you for allowing UNIPED to be part of this journey. We wish the Math Fair every success and look forward to the ideas and leadership that will emerge from spaces like this. Thank you.
Thank you, Ms. Ali. So, for those wonderful words, I think next time anybody goes to fill gas, you can stop UNIPED instead of NP, right? So, our final speaker for today is Dr. Inzamam Rahman, and what he's going to tell you about is, have you all ever heard about data science? Okay, well, if you want to know what it is and why it matters, we will welcome Dr. Inzamam Rahman to tell you a few words on that.
Okay, good afternoon, everyone. And as mentioned, I'm Dr. Inzamam Rahman. I'm a principal data scientist at the Guardian Group. That's the insurance company, not the newspaper. And I'm also a part-time lecturer in the Masters of Data Science program that's offered in collaboration with between the Department of Computing and Information Technology and the Department of Mathematics and Statistics. Just scroll down then. Okay, so as I mentioned, I'll be discussing a bit on data science today. We're very short, nothing too long. And data science is one of those fields that tends to resist a nice widely accepted definition. So this is my own somewhat opinionated definition of data science. What I would say is data science is a very interdisciplinary field. So it's usually laid within a bedrock of computer science, but it also incorporates, very importantly, ideas from branches of mathematics, or branches of what we consider mathematical sciences, such as statistics and operations research. And the idea there of data science is that what we want to do is we want to design, implement, and apply algorithms that allow us to extract value and insight from data. And in particular, what usually distinguishes, to some extent, data science from more traditional statistics is that with data science, we are often concerned with what we call observational or found data. So what I mean by found data. Okay, so experimental data and observational data, you'd find a lot of discussion on that in the statistics literature on distinguishing between these two very broad types of data sets. But found data doesn't really have a formal specification, but it's all around us. Okay, and found data differs from experimental and observational data because unlike experimental observational data, which is usually collected for a particular purpose, found data is collected just by the way. So whenever you scroll on TikTok, and TikTok macros, the very seconds that you spend looking at a video to decide what it should recommend, that is when data scientists then use that, that's considered found data. That's recorded by TikTok as part of its usage logs. If every time that you go to Amazon, you search up anything in Amazon, that's data that's generated just from using Amazon, not necessarily for the purposes of analysis, but just for Amazon to actually facilitate its operations, right? Its transactions. So that's what's different with found data. It's not collected to answer a particular question. It's collected as by the way, as a result of some sort of business process or some other operation. And its typical sources wouldn't be experiments or randomized controlled trials or surveys or anything like that. It would just be logs, transactions, things shoved into databases, sometimes even just paper-based forms, right? And there are some unique challenges to this broad category of data, right? In that sometimes the assumptions that you can make when it comes to experimental and observational data, you can't really make when it comes to found data, right? So the issues of bias of different sorts and different stripes, interfering with data. There's noise. The issues with actually teasing out causal effects from just associations. So it's challenging to work with found data, and in particular, because we have a lot of it. So like this slide here, this infographic, is about 3 years old and is incredibly out of date. Because we generate much more data than this on a daily basis, and it's only growing more and more with more and more devices connected to the internet, more and more business processes that do any sort of logging, okay? So you have this deluge of data that's just flooding, right? You have this flood of data, but to some extent, in terms of information, you have something of a desert, okay? And dealing with all of these issues and this massive variety and volume of data, there are a lot of tools that data scientists would use. Okay, so these are some of the tools that are popular in this day, right? But the interesting thing with all of these, right? So how many of you all know about things like ChatGPT and Gemini and stuff? I figure most of us here in this room, right? So that's already been transformative in terms of how we handle and process data, right? It has its uses even within data science as a field. So even to some extent, aspects of this are already out of date. And that's a continual theme, okay? Like, if you're using an algorithm or technique or a library from 6 months ago, you're already out of date, right? That's already like old news, right? But there is an underlying principle that it's good to consider, and that's that technologies, they have the shelf life of bread, right? But principles, they have the shelf life of honey, right? So bread, you go to the store, you buy a kiss loaf in about 3 to 5 days, right? You have mold in it, right? Anybody ever see spoiled honey? No, right? So principles are transcendent, okay? So that's why it's, of course, it's important to understand technologies. It's even more important to understand the underlying principles. because that is what enables you to thrive in a world that changes rapidly. And what do you think is your field that helps us develop those underlying principles? It's mathematics, right? So mathematics provides foundation upon which all these technologies are built. So there's this old quote that's attributed to Archimedes. It was, give me firm, and I'm paraphrasing it here, give me firm ground and a fulcrum large enough, and I can move the world, right? And that's essentially what mathematics is. It's that fulcrum for us to develop technologies and approaches that we can use to move the world. And why is mathematics capable of doing this? It's because mathematics is not just a body of knowledge. Okay? Sometimes we think of it, okay, mathematics, okay, how do you solve a set of simultaneous equation? What's the quadratic formula? What are the trigonometric identities? But mathematics is more than just those. No, those things, of course, very important. But mathematics is more than just those things, right? Mathematics is a way of seeing the world. It's a lens. As the philosopher Ludwig Wittgenstein would have said, the limits of my language are the limits of my world. And mathematics is a powerful language, and by virtue of being a powerful language, it relieves us of some of the limitations that we'd have otherwise. Because any tool, whether it's a hammer, a saw, a motor vehicle, what does any tool do? It takes our regular human capabilities and capacities, and it multiplies them while also decreasing our human foibles. And mathematics, because it allows us a lens to think about structure, right? And to be able to think in terms of assumptions, to detect and to interpret patterns, and to be able to suss out in a situation what's actually important for that situation versus what is just noise. Mathematics is a powerful cognitive tool. So in the same way, a hammer is a tool that helps your arm knock a nail into a piece of wood. Mathematics is a tool that extends the capabilities and capacity of your mind and your cognition, okay? And there are a lot of different aspects of mathematics, of course, that come into play in data science, right? This is probably a controversial point to make, but as a field, computer science, I would consider computer science almost the engineering analog to mathematics. In the same way that electrical engineering is to physics, computer science has a very similar relationship to mathematics. So there are a lot of mathematical concepts that shine through data science. And I just mention one in the interest of time, but one, of course, is probability, which I say is it should be no controversial statement to make, is that probability, of course, is the most important mathematical concept in data science, right? Why? Because we live in an uncertain world, and data embodies that uncertainty. And that uncertainty is pretty scary, right? Sometimes it's difficult to know things, it's hard to know things for sure. And probability allows us a way to sort of tame that uncertainty. And in a world where we are surrounded in a miasma of bias and noise, probability allows us a way to cut through that miasma, cut through that fog, and able us to still make sound decisions, even in the midst of all that uncertainty. In fact, it's probably one of the most important concepts ever created. And I'd also say, as a side point, I think it's important as well to study the philosophy of probability as well. I don't think it's good to divorce probability from its philosophical context. But yeah, so probability, of course, is a very important concept. It underlies everything you do when it comes to data, right? So with that, I'd like to thank you for your time.
Wow. Mathematics is the fulcrum to change the world, Dr. Rahman. Thank you for those words. Okay, guys, so with that, I'd like to close off the events here at the lecture theatre for today. Thank you to all of those who are still here in person. If you would like, you could go to the LRC Greens, the JFK Auditorium, and look at some of our other events. But with that, I think we would like to bring to a close the event here for today. Thank you all for coming out.
It is my pleasure and privilege to address you today at Math Fair 2024. I, Emily Ramsahai, am a product of a BSc in mathematics when I completed my double major more than 30 years ago. I went on to work in industry, manufacturing and energy sector, and also in my family business, and then more recently in academics when I completed my PhD in statistics. My first slide here today speaks about how mathematics gives hope to people. And that is because we believe that every problem has a solution. This mindset has served me well both in my professional and personal life, even in my sporting activities when I played golf at the national level. And I invite you to adopt this mindset when you consider choosing your BSc, and the BSc in mathematics will allow you to do this. Passion is important in life, and there are 6 ways that maths gave me the passion that I have in my life. The attitude to solve problems gave me that creativity and that entrepreneurial spirit. Also, many inventions have been done by mathematicians, some of which you may know: Pythagoras, Newton, Einstein. They changed the world, and mathematicians continue to invent. In the future, we will continue to build on the works of these mathematicians in all walks of life. When we work with numbers and think in abstract ways, we stand on the shoulders of these great giants. So the work of these mathematical giants continue to be used in the future to build new inventions, to come up with new ways to work. And mathematics gives us the framework to represent all situations and all problems. It is a universal language. The intelligence that mathematics will bring you will serve you well in this technology age. The future is in making connections with existing things and using logic to do this. One of the most obvious jobs that a BSc in mathematics will prepare you for is a math teacher. This is a very stable career, and it affords you the time that you need to spend with your family or work on your career or even your side business. There are also other jobs you can look into. Presently, globally, NASA and Google hire a lot of mathematicians, and more locally and regionally, we see government agencies hire mathematicians. But in the recent past, a lot of private organizations are setting up teams that include a mathematician. And why you will see this in STEM. STEM is where you see science, technology, E for engineering, and M for mathematicians. Other teams that you can find would be also in finance, legal, medical teams where you would find a mathematician. Some of these require technical writing, it requires understanding data, it requires manipulation of models, and it also requires predictions to be made so that decisions can be made on this. This final slide that I have here today is our coat of arms at UWI. At the top of this coat of arms, you will see the pelican. A graduate of UWI has the Pelican Pride, and I invite you to join this group by registering for your BSc in mathematics. Thank you.
Hi, I am Dr. Ian Ford, a lecturer at the Appalachian State University, a university in the University of North Carolina system. I was fortunate in that I did all my professional qualification at the University of the West Indies, St. Augustine campus, a BA in mathematics, a MSc in statistics, and a PhD in statistics. I did my MSc in statistics and PhD in statistics with the Mathematics and Statistics Department at St. Augustine. While doing my PhD in statistics, I was fortunate to have a supervisor in Dr. Vijesh Tripathi, current head of the Mathematics and Statistics Department at St. Augustine. I say fortunate because Dr. Tripathi is very versed in survival analysis and biostatistics. He sets high standards, demands high standards, and is always available to render assistance. While studying with Dr. Tripathi, he and I published a number of studies in high-impact journals. When it came time to seek out employment abroad, my qualifications had to be assessed, and I was really proud of the number of accolades that the University of the West Indies could have attached to the assessment of my qualification. I always knew that entrusting my education with the University of the West Indies and the Mathematics and Statistics Department at St. Augustine was a good choice. Those of you who have decided to make that choice, excellent, and I wish you all the best in your future endeavors.
Hi everyone, my name is Kriya Gopal and I'm a proud 2023 graduate of the University of the West Indies, specifically of the Mathematics and Statistics Department. Here at UWI, I pursued a degree in Statistics and Economics where I obtained first-class honors as well as the best level 2 and 3 performance in my respective discipline. I must say, none of this would have been possible without God, my family and friends, and most definitely the support and guidance that I've received from the lecturers and staff of the DMS. Being a part of the Department of Mathematics and Statistics has led me to vast opportunities for intellectual growth and success. As a student, I was able to broaden my knowledge and sharpen my critical thinking and analytical skills through the multitude of courses offered each semester. Their Mathematics Help Center also played a vital role as it allowed me to gain clarification on certain topics or even supplied additional learning material for courses that I may have struggled with, specifically real analysis and linear algebra. My degree has also fueled my passion for data analytics. Fortunately enough, the DMS also offers short courses, usually during the vacation period, where you can learn how to use software such as R, Power BI, Excel, MATLAB, all of which are utilized by big companies today. Outside of academics, UWI also promotes holistic development through their fairs and clubs. For example, I was a part of the Actuarial Science Club and the Economic Society. These clubs provided me with a platform to strengthen my interpersonal skills, foster amazing friendships amongst a hub of diverse individuals who shared similar goals as me. These extracurricular activities also served as a medium to de-stress when my workload was becoming a bit overbearing. So without hesitation, I would have taken part in activities such as games nights, hikes, etc. Upon completion of my degree, I was blessed enough to secure 2 jobs, one right here at the department as a part-time demonstrator, and I'm truly grateful for this experience and to know what it is like to be on the other side of the classroom. And I must say that I have a greater appreciation for the efforts and commitment my lecturers and tutors would have made for me as a student. Currently, I am a graduate trainee at Proman in the Supply Chain Management department. For those of you who may not know, Proman is a Switzerland-based company and a global leader in natural gas products, including methanol, ammonia, melamine, and UAN. This company has about 14 petrochemical plants situated in the heart of Mauritius and is continuously growing worldwide. In supply chain, our job is to essentially support the engineers and technicians working on the plant. It's our responsibility to have proper order processing, build relationships with suppliers, improve distribution networks, as well as plan and analyze inventory through database systems to ensure optimization. It is a very fast-paced environment, and I truly believe getting into such a prestigious organization and adding value to Proman even as a graduate trainee would not have been possible without the respective tools, skills, and knowledge that I have acquired in my tenure at the DMS and by extension, UB. To close, I want to say that the DMS will always hold a special place in my heart. The 3 years spent here were very transformative as it represents hard work, dedication, perseverance, minor setbacks, and occasional tears. I urge everyone who are currently enrolled in UWI or have intentions of joining this prestigious organization to come in with an open mind, have new experiences, learn as much as you can, and utilize all the resources that are made available to you, as this will contribute to you being an all-rounded person and having a competitive edge in the workforce. Thank you.
Good day. My name is Mr. Hassan Mohammed, and I'm a lecturer in actuarial science in the Department of Mathematics and Statistics at the University of the West Indies. I welcome you to this math fair, and today I'll be talking to you about risk measures in actuarial science. First of all, I'd like to briefly explain what is actuarial science. Actuarial science is a field of study that brings together mathematics, statistics, probability, economics, accounting, computer science. It brings together knowledge from all of these fields and applies that knowledge to real-world financial problems. The actuary who uses actuarial science attempts to mathematically quantify the risk of financially adverse events. What are financially adverse events? This slide shows you some examples: an earthquake, a car accident, some personal injury. Such events can be financially catastrophic to the person involved. And so, people have used insurance as a way of mitigating the risk of these financially adverse events. As such, actuaries who try to quantify these risks, they have traditionally found employment in insurance companies. However, graduates of a degree in actuarial science have a wide array of career paths open to them. And we have had graduates who have found employment as a professional actuary. Yes, that's the traditional career path. But also we have had graduates who have found employment in the fields that you see on this slide, as a risk analyst, as an investment analyst, as a financial consultant, as a data scientist, and indeed there are many other options. Now, the traditional path to becoming qualified as a professional actuary, if you want to to follow the career path of being a traditional professional actuary, the path to doing that is to write the professional examinations of one of two professional actuarial associations, either the Society of Actuaries in the US or the Institute and Faculty of Actuaries in the UK. Students must write the examinations of one of these associations to become a certified professional actuary, but these examinations are conducted independently of UWI. Please bear in mind that many graduates of degrees in actuarial science do not pursue these professional examinations, and they still successfully find employment in various industries utilizing their knowledge of risk management and risk analysis. And so I would like today to talk to you about risk measures, just to give you a glimpse of some of the work that actuaries do. One role of the actuary is to mathematically quantify, as I said before, the risk of financially adverse events. One way of doing this is by using risk measures. A risk measure attempts to quantify the uncertainty in an insurance claim amount. So, as an example, suppose we model the monetary value of an insurance claim by a random variable x, which has an exponential distribution with mean theta. And in this example, theta will be 1000. Well, the mean or the expected value of this exponential distribution, of course, is 1000, which we can denote by EX, expected value of x. Now, we may use the expected value of x, 1000, as an estimate of the amount of assets needed to pay insurance claims. The insurance claim will be a random amount. However, the expected value will be 1000. And you may say, well, the insurance company just needs to reserve $1,000, 1000 units of monetary value in order to be able to pay claims. The problem with that is that for this exponential distribution, the probability that a claim exceeds the value of the mean, E of x, the mean, the probability is 37% that a claim will exceed that value, will exceed that mean value. And so if the insurance company simply reserves $1,000 in assets, the mean value, the expected value, and the insurance company reserves that amount to pay expected insurance claims, then the probability that it will become insolvent is 37%. That is more than 1/3. This expected value then, it does not account for the uncertainty in the actual claim amount, because the reality is that we don't expect every single claim to always be $1,000. There's uncertainty, there's variance in the claim amount. So a risk measure attempts to quantify that uncertainty in the claim amount. And I'll just introduce you to one such risk measure, which is called the value at risk at the P% level. And it's denoted by VAR subscript P, the value at risk at the P% level. That value at risk at the P% level is the amount of capital or assets that the insurance company needs to reserve, to put aside, in order to limit the probability of becoming insolvent to 1 minus P%. So that value at risk is a value such that the probability that the claim exceeds that value will be 1 minus P. And if you decide to study actuarial science, in one of your courses, you will be able to derive an expression for that value at risk, for the exponential distribution, which will turn out to be minus theta by ln of 1 minus P. And so, for the exponential distribution with theta equal to 1000, the value at risk for a level of P of 0.95, of 95%, that works out to be $2,995.70, 2995.7. And as you can see on this screen, the probability that a claim will exceed that value at risk will be only 0.05, only 5%. And so that risk measure, the value at risk at the level of 0.95, it limits the risk or it limits the probability of becoming insolvent to only 5%. And so, as I said, if the insurance company reserves that amount, 2995.7 in assets, to pay expected insurance claims, the probability that it will become insolvent is only 5%. And so this risk measure, the value at risk at the P% level, it accounts for the uncertainty or variance in the actual claim amount. So I do hope that this brief introduction to a risk measure has whetted your appetite for learning more about actuarial science. And I do encourage you to consider enrolling for the or applying for the BSc in Actuarial Science at the University of the West Indies. Thank you for your time and thank you for listening attentively.
Welcome to the exciting world of mathematics. In this video, we'll embark on a journey to explore the wonders of mathematics and its importance to our everyday lives. We'll be talking of one type of mathematics since there are many branches that is very difficult to quantify in one single video. But first, we have to ask ourselves, well, what is mathematics? Well, mathematics is very difficult to define in a single sentence or phrase, but really it's just a study of numbers and shapes and patterns and structures. If we really think about it, mathematics itself is the entire language of the universe, guiding us through the mysteries of the world around us. So, with that, let's get started. Let's start with numbers, which are the building blocks of mathematics. Numbers help us to count, measure, and quantify the world around us. But why is mathematics important? Well, because it helps us to develop problem-solving skills, which in turn helps us to develop a critical thinking skill, which allows us to make informed decisions about problems in which the solution may not be easy for us to understand. So, now that we're talking about mathematics and why it's important, and not just all these crazy numbers and symbols and all that, we can think about some real-world examples of where mathematics is really important to us to help us solve some problems. So, we can talk about one of the most important and popular ones, which is called engineering, which is applied mathematics, which occurs around us all the time. And the second most popular real-life application of mathematics, which is in the sciences itself, one of which we'll be speaking about today in chemistry itself. So, since we've spoken about some real-world applications of mathematics, let's go a step further and ask ourselves, well, why mathematics in the first place? Well, we can use mathematics to quantify things like cooking, traveling, and economics. By doing this, we can analyze problems that we may have in real life, create a strategy in order to solve these problems, and finally, execute these plans. So, now that we have this, we can be able to talk about our main topic today, which is symmetric graphs and graph theory. But before we do that, let's just touch on some career opportunities in mathematics, which are very popular in today's world, such as STEM careers and most recently being a data scientist. Here's some fun facts about mathematics, some of which you may have seen before, but did you know that 0 is also an even number? So, with that, let's get started in mathematical research and practical applications, one of which is called the Szeged Index. This index is and other intricate mathematical concepts. This is really the essence of mathematics. It appeals to our curiosity as well as our creativity. So now that we have laid the foundation, we can continue now to talk more about this in our next part of our video, which is called an introduction to mathematical chemistry. In this section of the video, we'll be speaking more about mathematical chemistry and chemistry itself. So, What is mathematical chemistry? Think of it as a field where mathematics meets molecules and reactions, which allows us to analyze and understand chemical phenomena using mathematical tools. So, chemical structures are really just complex arrangements of atoms and bonds that determine the properties and behaviors of molecules. So, how can we apply this? Well, applications of mathematical chemistry are very wide and diverse, but one of the most popular ones are drug design and development. So, by integrating mathematical techniques with chemical principles, researchers can develop new drugs and design innovative materials and address environmental challenges more effectively. So, mathematical tools such as graph theory will help us here to represent these structures as mathematical graphs where atoms are vertices and bonds are edges. So, chemical reactions involve the transformation of reactants into products through a long series of steps. Understanding these reactions is really crucial in chemistry. Mathematical models such as reaction kinetics equations and rate laws will allow us to predict reaction rates and outcomes based on mathematical principles. Mathematical methods, including computational chemistry and molecular modeling, will help us and enable us to analyze and predict these properties with great precision. So, we see that mathematical chemistry has diverse applications across various fields, including this drug modeling discovery, material science, and environmental chemistry and bioinformatics. Now that we have defined this, we can move on to our final part of this video, in which we talk about chemical graph theory, which is our crucial part of this video. Now, we have reached the final part of our video, which is chemical graph theory. So, once again, we have to define exactly what is chemical graph theory. Think of it as a branch of mathematics that studies the topological aspects of chemical compounds by representing them as graphs. So, essentially, graph theory is a study of graphs, which are mathematical structures consisting of something called vertices, which are nodes, and connected by edges, which are sometimes called lines. So, chemical compounds are just complex arrangements of atoms and bonds that determine their properties and behaviors. So, how are these represented? Really, in two main ways. One way is by graph representation, which is the essence of this graph theory, and the other is by mathematical models. So, we see by representing these compounds as mathematical graphs, we can analyze their structure, its connectivity, and other interesting properties by using this graph theory. And why is this important to us? Because its impact on chemical structures in two main ways. One, it's its structural diversity, and secondly, it's the functional group that is associated with these compounds. So, by applying graph theory concepts to chemical compounds, we see that researchers can predict molecular properties by designing new drugs and even optimizing chemical reactions more effectively than it was previously done. So we see in conclusion now, chemical graph theory provides a powerful framework for understanding the structural properties of chemical compounds using graph theory concepts. So, thank you for joining us on this introductory exploration of chemical graph theory, stations between chemistry and graph theory. Sometimes in life, before we even begin our journey into mathematics, we may think that it's very difficult to get started. So, We get overwhelmed at times about how to even begin this entire journey. But always remember in life, it's not really about how we begin our journey, not only in academia, but rather how we end our journey in academia or in life itself. Good luck, and I hope you enjoyed the video.
I am the head of the School of Humanities and Education at the UWI in Bermuda. I'm also a lecturer in mathematics and education. I'm really excited to be here to talk to you about an aspect of math sometimes people usually don't realize. It's the aesthetically appealing, beautiful, exciting mathematics. Hope you do enjoy. Most of the times people ask themselves, what is mathematics? And here I'm just sharing with you, these are several quotations. You could just look at them briefly. But interestingly, do you know where these things came from? They talk about math as being at least 5,000 years old. But there's something even more pertinent with this, is that this is taken from our national curriculum. And there is a national curriculum for mathematics in Trinidad and Tobago for all various levels, from primary all the way up to Cape level. And it's not the mathematics syllabus for CSEC. What it is, it's a document that talks about things that you should really learn while you're doing mathematics in school. And one of them is the aesthetic appeal of mathematics. Mathematics is everywhere. Just take a minute and just think about it. When you look at even a spider web, there are patterns and shapes that you see. Even with numbers, there's that appeal when you do various exponential things with numbers, patterns jump out at you. Then there's geometry. Geometry is really exciting because just look at the shape, the colors, the artwork, it reveals something. There are patterns that use concepts in mathematics that really make this thing interesting and eye-popping so that you can really see the beauty around you. With that, there is something that someone spoke to you about, I think last year, Math Fair. It's called the golden ratio, the beautiful, appealing mathematics we see every day. What really is the golden ratio and the Fibonacci sequence? Well, let's just watch this nice animated clip for you to see. Enjoy.
Counted the number of petals on a flower? If you counted them on a flower with petals all intact, you would likely discover that the number of petals is a Fibonacci number, that is, a number from the Fibonacci sequence. Many flowers have 3, 5, 8, 13, or 21 petals, all of which are numbers in the sequence. The leaves of cacti and the seeds of sunflowers are arranged in both left and right-handed spirals. The numbers of seeds or leaves in these spirals are also generally in the Fibonacci sequence. We have 2 hands, both of which have 5 fingers, and each finger is divided into 3 parts. All of these numbers are also Fibonacci numbers. Moreover, the lengths of the bones in our hands also fit into Fibonacci ratios. So, what's the Fibonacci sequence anyway? And why is it seemingly everywhere? The Fibonacci sequence is a series of numbers in which a given number is the result of adding the 2 numbers before it. So, if you start with 0, the next number will be 1, followed by 1, followed by 2, followed by 3, and so on. As you can see, every number in this series or sequence is obtained by adding the 2 preceding numbers. Individual numbers in this sequence are often referred to as Fibonacci numbers. Mathematically, the Fibonacci sequence is represented by this formula, where n is greater than 1. You can use this expression to find any nth digit in the sequence. This fascinating sequence is widely associated with the mathematician Leonardo Pisano, also known as Fibonacci. He hailed from the Republic of Pisa, which is why he is also known as Leonardo of Pisa, and is considered to be one of the most talented mathematicians of the Middle Ages. At the time, Europeans were still using Roman numbers, while Hindu-Arabic mathematicians were using a different number system that was more robust and efficient. Fascinated by the brilliance of the Hindu-Arabic numeral system, Fibonacci brought it to the Western world in 1202 through his now famous book, Liber Abaci. In the book, he reviewed and compared the Hindu-Arabic numeral system with other systems, such as Roman numerals, and described how using the Hindu-Arabic system made calculations faster and easier. Although his book contains the earliest known description of the Fibonacci sequence outside of India, It was described in ancient Indian texts by mathematicians as early as the 6th century. So, what makes this Fibonacci sequence so special? To the uninitiated, this famous sequence may just seem like a series of numbers, but the Fibonacci sequence has been discovered and rediscovered in various forms, not only in mathematics, but also all across the natural world and in our everyday lives. There's also another exciting offshoot of the Fibonacci sequence, the golden ratio. Suppose you have two quantities, A and B, wherein A is greater than B. Now, add A and B and divide that sum by A. If this ratio comes out to be equal to the ratio of A and B, then you can say that A and B have a golden ratio, which is represented by the Greek letter phi. Write down the Fibonacci sequence on a piece of paper and calculate the ratio using this formula. You will notice that all Fibonacci numbers have the golden ratio, the value of which is close to 1.618033. In geometry, when the golden ratio is applied as a growth factor, you get a special type of logarithmic spiral, known as a golden spiral. Simply put, a golden spiral gets wider by a factor of phi for every quarter turn it makes. You can find examples and manifestations of the golden ratio and golden spirals in countless places in your everyday life. Seashells are some of the most common examples of the golden spiral found in nature, but ocean waves, hurricanes, flower buds, snail shells, and spider webs are just a few of the other naturally occurring examples. Many artists use the golden ratio or the golden spiral in their creative works. Legendary painter Salvador Dalí explicitly used the ratio in his masterpiece, The Sacrament of the Last Supper. Architects also commonly use the golden ratio when designing buildings and other massive structures. Popular Swiss-French architect Le Corbusier, who is widely acclaimed as one of the pioneers of modern architecture, explicitly used the golden ratio in his modular system. From snail shells, flowers, and bananas to the inside of the human ear, iconic buildings, and galaxies far out in the cosmos, the golden ratio can be seen everywhere. This is probably why it's also known as the divine proportion.
Wow, pretty cool stuff. And as you can see, there are many places where we can see the beauty of mathematics. As we mentioned before, various parts of nature. But you know, there's something even further you could really understand. Mathematics can even be in our culture in Trinidad and Tobago. So if you look here, this is something teachers did with some students. They identify and classify the shapes in the costume, the carnival costume, and the teacher asked them, could you identify the lines of symmetry? Well, fits nicely with doing a math lesson during carnival, don't you think? Well, there are other things. You can look at wire bending art form to create, as you see in this particular costume here, you are seeing that the student made a costume that used various shapes and patterns, and by the circular shapes, they were able to create a costume. These are things that are useful where math is applied. And symmetries everywhere in the way you paint the colors and you distribute certain lines and angles, we get beautiful creative stuff. Even in national pride, we see here, you can see the shapes, the lines of symmetry in our national flag and our coat of arms. And then even the steel pan. You can get some wonderful things you can learn about in maths. Here, by using a single stick on a tenor pan, you can play certain songs and see what shapes could be formed. This is something called pan geometry. So folks, math can be beautiful, appealing, and you can see the aesthetics of it. I do hope you think about the architecture and the world around you. And as we close, I'm just going to leave something that really plays with your mind, the work of mathematicians. It involves identifying patterns. And when you see a pattern, you test it out to see if it works for all cases. You develop a non-proof argument without the formal things in math. And then when you learn the correct things like logic and various concepts, you can construct a proof. And remember to put your little box at the end of QED. Don't forget that. But as we close, I'm leaving something fascinating with you. It's a short clip about the beauty of mathematics. Do enjoy. All the best, students. Mathematics is around us. Look for patterns. Be alert. Make your conjectures. And don't forget to write your proofs. All the best. Bye.
Good morning, everyone. My name is Navin Dukiram. I am a PhD statistics student in the Department of Mathematics and Statistics at the University of the West Indies, St. Augustine campus. And today I would like to talk about the topic of predicting fortunes with mathematics, the power of statistics and data science. To start, let us talk about data. What is data? Data is just information that is maybe conveyed through some kind of value or fact or meaning. And data surrounds us. Data is everywhere. Think about when you go to the grocery. Think about when you go to the bank. Think about when you go to school. With the rise of internet, data surrounds us. It becomes so much more abundant. Everything is data. So we get a lot of data from things like social media and from websites and from companies that store data on their customers. And so data is really becoming a very important, or it has already become such an important part of life. And we can use this data to help us, right? So data science is a tool used to make accurate forecasts and predictions from the data. But what is data science? Well, data science is a field that extracts insights and knowledge from various forms of data. And the three main components in this data world are data collection, where how do we extract and collect the information that we want, data analysis, which is how are we going to organize and interpret this data, and then how can we use the data to our advantage in terms of making forecasts and predictions. Predictive analytics, which is what data science does, is very important because predictions help us to make better decisions and it helps us to become more strategic. So it helps us become smarter by becoming more strategic thinkers and more strategic decision makers. And as we saw, data is everywhere in the real world, and therefore data science lends itself to a lot of real world applications. So for example, we could do stock market predictions, climate change predictions, predicting outcomes in sports, advancing healthcare, advancing education, looking at transport in terms of maybe traffic prediction or transport routes, and also alleviating crime, which is the topic of my research currently for my PhD. Now, how exactly is predictive analytics done? Well, we use something called statistical algorithms and machine learning, and we apply that to the data to identify the likelihood of future outcomes based on historical data. So essentially, we are using the past to predict the future. Now you may ask, what are statistical algorithms and machine learning? So statistics is really the science of data in terms of data analysis and how to interpret the data and how to represent the data and how to collect the data. So statistics is all about the data. Machine learning, on the other hand, is really telling the computer how to learn without explicitly following instructions. So that is done by the computer. And a machine learning algorithm is really an algorithm where the computer is going to learn how to solve a problem, and it could actually pick up on the patterns without a human telling it what to do. And so it could learn on its own and become better on its own. So this is what we want. We want the computer to become smart, and in order to do that, we could use mathematics, right? Because mathematics is smart. And so when we do that, we will get good predictions and become more strategic in our decision making. So I want to reiterate that data science is really looking at patterns or extracting patterns from the past or historical data and using those patterns and trends to generalize to something in the future that we haven't seen before yet, right? Now, in the data science process, we have a few things that we'll have to go through in order, right? And actually, it's really a cycle. We start at one thing, and then it's not as if we stop. It's a continuous cycle of refinement, because the model always, or the data science problem, is always something that has to be improved upon as time goes by, right? So we first might start off with collecting the data. And how will we get the data? We could get it from surveys, we could get it from questionnaires and interviews, we could scrape the data from the web and get it from social media posts, etc. So collecting data is very important, right? Because we need to get the data. Then we have data cleaning and processing, which means that we need to format the data to suit our needs. We need to remove all of the corrupt parts of the data. We probably need to format the data better to suit our algorithm procedures, right? We probably need to deal with missing data and things that could make our predictions go wonky, right? And then after that, we can visualize and explore trends and patterns in the data. So machine learning and data science is all about trying to find the meaningful patterns, or recognizing those patterns that are relevant, right? And so we could do that through visualizing graphs and charts and exploring relationships between one set of variable with another variable, and see any kind of interesting trends that might exist. And that could help us build our model, right? And a model is really a representation of some kind of phenomenon that is in the real world. So it's not going to accurately capture the real world, but it's going to be a mathematical representation of something that can be close to that, right? And so when the model building is really the heart of the process of machine learning, and that's where we could apply our statistics and calculus and linear algebra, and all of the mathematics into that. So for example, we could use linear algebra to represent our data in the forms of matrices and vectors, right? That's usually how data could be represented. We could use statistics to manage uncertainty and create probability models to account for random variation in the data, and to try to extract the patterns and ignore the noise or the errors in the data. We could use calculus, which is the study of change, in order to optimize something. So the algorithm might want to minimize the loss or how much error that it is included in the model, or it might want to minimize some cost, right? And so we need all of these tools, right, in order to build a good model. Now, how will we tell if the model is good? Well, we have to do model evaluation, which means we have to check our data, right? Remember, we have our historical data. We are going to compare our model results to the actual results, which we know because it already happened and we know what has happened. So we have the actual results that happen, and so we can compare our model results to the actual results and see what is the difference. And if the difference is very small, then that means our model is very good. It has a high accuracy, for example, and so we can be confident in saying that this model will work well for future data sets. It can generalize well to a new data set that we haven't seen before, or data that hasn't occurred before. So we could then deploy the model. And model deployment is basically putting the model out into the real world and getting it into something called production. Let us look at an example. So remember, everything is in data science will fall back on some strategic decision to make. So let us say you want to predict whether your friend will watch the new Avatar: The Last Airbender Netflix TV show. And we could use that prediction to inform Netflix on whether or not they should recommend it to him or her. And so if we look at this example, we might think of what variables or features we might want to collect that will help us to predict this outcome. So it's either your friend would either want to watch the show or he or she will not want to watch the show. And this would probably depend on a number of user preferences. So maybe you might collect things on their age and their gender and their ethnicity and their country and their background and whatever kind of cultures they have, right? They might be more interested, if they are interested in fantasy, they might be more likely to watch a show like this. Or if you have friends or people who have similar interests to your friends and you see that, okay, they watch similar shows, then you could use that information and incorporate it into your model. Maybe they watched the show, the animated series in the past, or maybe they watched the first live action movie that came out like maybe 10 years ago. Maybe you might want to figure out what are their thoughts on that show and use that as a feature in the model. And so you want to try to figure out what are the strong relationships that might exist in historical data that might suggest, okay, if my friend is this way and he or she likes this and that, then maybe potentially they would be interested in this. And it's not really a guessing game, right? We actually coming up with some kind of concrete number or concrete metric that will say, okay, my friend would probably like this with a 65% likelihood, right? So that is basically how you would kind of use the machine learning or data science workflow to obtain your prediction. So you go through all of the phases and you refine your model, and then you will come up with your prediction. Can data science work for you? Well, we saw how data science could be used to predict fortunes and how much fun and exciting it could be. But can data science be used to make you a fortune? And the answer is yes, because there are a lot of jobs in data science that are in high demand, such as data analyst, data engineer, data scientist, machine learning engineer, and the list goes on, right? And so I invite you to go deep into this field. You will need to have a strong mathematics, statistics, and computer science background. But trust me, all of these fields are so much fun and exciting to explore. And so I wish you all the best in your future endeavors, and I hope that you learned something from this presentation. Thank you.
Hey everyone. So my name is Anand Rampadar, and I was asked to give you all a quick, like 10 minutes talk to try to inspire some of you all into pursuing mathematics here at UWI to see like how far and what you could do, where you could reach with the degree in mathematics. So so yeah, so let's see who am I. So about me. So I'm currently a senior bioinformatics engineer slash modeler at the New Zealand Institute for Plant and Food Research. And I'm based in Auckland, New Zealand. And I've been in this role since September 2022. So a bit more about me. So I did my high school in St. Stephen's College in Princeton. So pick up any St. Stephen's College students who attend in here today. So part of Princeton, as we know. From 2000 to 2006. After that, I decided to do my bachelor's, my BSc in both mathematics and physics, so a conjoint degree at UWI St. Augustine in 2006 to 2009. I didn't do so good, to be honest. In the bachelor's, I got a lower second class honors, which is effectively a C when you really think about it. So ABC, so I got effectively a C. Still, it was good enough to at least be to enroll in the masters at UWI in masters in maths. Not sure if that's still the requirements, but at that time it was. Um, luckily for me, I redeemed myself and I'm getting a distinction, which was an excellent grade for the masters. I did that between 2010 to 2012. I did it part time as well because at the time, have to work, right? So I was working in UWI and UWI Open Campus as well as Costa during that time. So around 2014-ish, I was started to look for PhD scholarships. And luckily I was awarded a scholarship to pursue my doctorate PhD in mathematical biology at University of Auckland in New Zealand, and the scholarship was funded by the Royal Society of New Zealand's Marsden Fund is the name of it. So in the future, you all could look up such scholarships. So was awarded scholarship, and in around 2015, so in September of 2015, hopped on a plane, my wife and I, and moved to New Zealand for me to pursue this crazy thing called a doctorate in mathematical biology. So as part of a PhD, you just have to come up with a thesis. So everyone you meet here today with a PhD would have done the equivalent of this. Mine was on asthma. So I basically modeled asthma for PhD. So I looked at the mathematics associated with airway closure during asthma attacks. So, if anyone here suffers with asthma and gets an asthma attack. So what happens is effectively your airways collapse or constrict and prevent the air from flowing through your lungs to your blood. So yeah, I basically modeled that during PhD. It was cool, has a lot of maths involved in it. So PhD was between 2015 and 2018. So did that and in 2018 self, when I finished PhD, moved across to the Auckland Bioengineering Institute, also in New Zealand, to do postdoc research. So I was there for 4 years. I did quite a lot of research over there, but specifically into like human physiological or biological processes. So basically, like all like maths around how the lungs and heart and stomach work. You'd be surprised how much maths they have involved. It has in that. There's a lot of cool stuff. So I did that for around 4 years, and specifically, I was part of I was lead researcher for a group. It was part of a bigger project that is building virtual digital twins of humans to help predict personalized health. I'm still kind of part of it, although I've left them. I'm still kind of part of it. So in around September 2022, hopped across to the plant world because I was interested in plant stuff at that time, and which is where I am now. So in plant and food research. So of the things that I'm doing, one of the cool stuff that I'm looking at is trying to investigate the effects of large, changes in climate and weather, what effect these things have on the DNA of fruits and fruit quality, fruit health, etc. So it's pretty interesting. There's a lot of maths and biology in there as well. And to do this, we're also looking into, I'm using like machine learning and AI tools to help develop new and new plant and vegetable cultivars, so versions of existing plants that will grow better in like ever changing climate. Climate change is a thing, and we need to design plants that are existing plants that are resistant to flood and diseases and these things. So that's where I am right now, and that's some of the research that I'm doing. But what helped me to reach here? So if there's one thing that I keep saying wherever I go in the world and whichever group of sciences or universities or whoever I meet, I like to tell them that, look, I am still a product of UWI, of University of West Indies, specifically the Department of Maths and Stats, as well as physics for undergrad. I also did physics in undergrad, but yeah, so I am a proud product of UWI because you see these degrees, they did um, set the foundation for my PhD at Auckland. So it was more than sufficient, specifically the mathematical modeling and programming courses at both undergrad and postgrad, at masters and at bachelor's and masters. They made the learning curve much easier to survive. As well as the pure maths courses, not only the applied maths courses, but the pure maths courses also helped. Because sometimes you're trying to solve things, and no matter what you do, it's not solving. And reasons because of some theoretical reason why. And pure maths courses actually helped me understand why certain methods wasn't working. So basically, all I had to do for the PhD was to learn the biology, which wasn't that easy, but it was good that I had the maths knowledge already, and it was just really to learn the biology and probably learn a few more advanced math methods, which was built on stuff that I had learned during bachelor's and masters, right? So that was definitely a plus. So something that students need to know is that both TBSc and master students at UWI, they are comparable to the international programs, at least in maths and stats and ComSci as well. But they are accredited and recognized internationally, so you don't need to worry about it. And they are comparable. So the same thing you learn is effectively same thing that students in New Zealand and Australia learns. But the key thing though is that you need to have good grades. If it is you want to leave, you need the distinctions. You need your first class honors. I mean, I was fortunate that I ended up getting the distinction in masters. I mean, I worked tough hours on that. You can ask Dr. Rao and Dr. Daga and Dr. Daya and them about that. But I had worked some crazy hours during that time, but still managed to get a distinction. But without that and the good recommendations that I got from them, I probably would not have gotten the scholarship, which means I wouldn't have reached here. So, although UE provides you with the necessary background and everything, you still need to get really good grades to be able to make it. So some advice to Caribbean students. So this is one of the things that thought I think about a lot, is that we are currently in the age of big data and informatics, and there will be a definite need for people to develop new large scale predictive methods to solve some of the big problems that the world is going to face or is currently facing. And while of course using machine learning and AI tools will become commonplace, it already is, but it will be much more common than it currently is. And it's important that you know how these things work and whether these results are trustworthy, because you can model anything, but if it makes sense, that's the key, right? And to be able to know if these things make sense, it would require a society that is highly skilled in mathematical sciences as well as statistics and computer sciences. So these things are important for to face the future and face the problems that world is going to face. So as students of the Caribbean, you need to know that these things are going to affect you, and you do have the background at the universities to do these things and to reach here. So that's important, which brings me to that point that, look, no matter where you come from, which island, which country, which part of the country you're from. I mean, I'm from a small place called New Grant, after Princestown. If anybody from New Grant, but originally from there, a real small place in Trinidad. But I had my grades. I managed to get a distinction, and my maths grades for undergrad wasn't so bad too. But you need to understand, no matter where you're from, so long as you have your grades and you strive for excellence, you could make it. You could achieve great things, and you could reach places you never even thought, you never even imagined that you would reach, right? And it's important, again, to reiterate that your degrees in UE in maths and stats as well as computer science. It can give you the foundation that you need. You just need to be brave, have your grades, and push yourself. You all can make it. I'm confident. Caribbean have some of the brightest people that I've met, equivalent to all the MIT and Harvard and these places. So you can make it. A degree at the University of West Indies in maths and stats, it does provide you with the necessary background. So I would recommend it if it is within your ability to do it. So yeah, that's me, I guess. Yeah. That's my email. Feel free to reach out. Don't send me any spam, please. But yeah, I'm happy to talk to anyone if anyone needs some advice on things. And yeah, I wish you all the best for the math fair. Hope you all have enjoyed with math fair. And yeah, that's it. So all right, laters.
Good day, my name is Kershawal, and I'm here today to speak about my journey during the University of the West Indies, and by extension my time being a part of the Department of Mathematics. I recently graduated from University of the West Indies with a BSc in Actuarial Science with first class honors, and I am currently pursuing an MSc in Statistics part-time while working full-time at the Beacon Insurance Company Limited. I entered the University of the West Indies in 2020 during the height of COVID-19 pandemic, where classes were online and there was a difficult transition going from Form 6 to university, where you had to stay at a screen the entire day and was confined to your home. I was accustomed to learning in person while seeing the work being written on the board, but now I had to quickly adjust to the new way of learning through the utilization of the computer. My degree was based in mathematics, so I was exposed to courses that contain calculus, sets and number systems, linear algebra, and analytical geometry in year 1. Each course pushed me to stretch the boundaries of my understanding and approach problem solving with creativity and precision. Year 2, I became familiar with probability and statistics. This is where I first grew to like statistics, and by year 3, stats courses were my favorite, and thus this persuaded me to return and pursue my master's in statistics. The reason I chose to do a degree based in mathematics is because there's a solution to every problem. You are guaranteed to find an answer to your question because this is the one area of study that guides you in the search for an answer, and it lets you know where you are on the wrong path. In my time here at the University of the West Indies, in the maths department, I met many wonderful lecturers who ignited a passion for learning and guided me through the labyrinth of mathematical concepts. Their dedication to the department and unwavering support shaped my academic journey in ways I could never have imagined. The problem-solving mindset and logical reasoning cultivated in the mathematics department turned out to be instrumental in securing my first job. Employers recognize the value of a mathematics education in fostering critical thinking and analytical skills, qualities that are highly sought after in today's competitive job market. The ability to approach complex challenges with a methodical, strategic mindset, a skill honed during my time here in the mathematics department, became a defining factor in my professional success. I was fortunate to meet lecturers as they guided me in my journey during university and assisted me in getting a job at the Beacon Insurance Company Limited. I'm also a part-time demonstrator for the University of the West Indies. I mark papers for the department and assist them for special events such as today, the Maths Fair. This gave me the opportunity to experience how things function on the other side of the classroom. Furthermore, one of the most useful tools that the Maths department has to offer is MHC. This service is one of the most essential and helpful service as it allows students to come in with any mathematical questions they have that may not work for you. So take some time and figure out what works best for you. The University of the West Indies also holds many work recruitment programs. One of them I attended was called World of Work, also known as WOW. This program allows students to talk to various representatives from many companies, from many prestigious companies in various sectors of Trinidad and Tobago, and make an impression on them. These companies are actively seeking to recruit new persons, so you are able to hand out your resumes in hopes of getting employment. These companies will keep your resume on file and will call you if you fit the criteria for their vacancies. When I attended in 2023, there were 44 companies present. Republic Bank Limited, Linus & Young, Methanex, Shell, and PwC were some of the few companies present on that day. This is a program that is held yearly, so I would highly recommend attending this event. I thoroughly enjoyed my degree, the good and the bad that came with it, because we all know there will be challenging times no matter what degree you decide to pursue. But don't let that deter you and make you forget about the good times. Remember that as much as university is a place to gain an education, it is also a place to make lifelong friends. Enjoy this time and ensure you have a balance between work and a social life, because you do not want to live the rest of your life with regrets. Either regretting that you did not do enough in your schoolwork or did not get.
Professor Rosemary Bell Antoine, Campus Deputy Principal Professor Indar Ramnarain, the Dean in the Faculty of Science and Technology and Senior Lecturer Dr. Brian Coburn, Head of the Department of Mathematics and Statistics and Senior Lecturer, also my Master's Thesis Advisor, Dr. Vrijesh Tripathi, and the Chief Education Officer in the Ministry of Education, Trinidad and Tobago, Dr. Peter Smith. Thank you all so much for having us with you today. My name is Laurie Selby, and I'm a PhD candidate at Arizona State University and a UWI alumna. And we have the pleasure and honor of having with us here today Professor Jeffrey Wilson, Professor of Statistics and Biostatistics and Associate Dean of Research and Inclusive Excellence at W.P. Carey School of Business at Arizona State University, who is also UWI alumnus. Welcome, Professor Wilson.
Thank you very much, Eloy. I'm happy to be here. Good morning, everyone, or good day, everyone.
So, Professor Wilson, we want to pick your brain a little bit as a UWI alumnus. Tell us a little bit about your background in the field of statistics.
My background in the field of statistics started back in the island of Trinidad. I am a graduate of Queen's Royal College, and then I went to UWI. And during my time at UWI, I came in contact with Dr. Sincere, who was an econometrician. I came in contact with Dr. Farrell, who was teaching there in the Natural Sciences building. And then I came in contact with CSO and Dr. Puhadas, as well as a professor who came all the way from Penn State University. And among all these folks, I was introduced, and that's where my background in statistics started. From there, I went to the great state of Iowa and Iowa State University, where I got my master's and PhD. I went on to teach at the Oklahoma State University, and then Arizona State University made me an offer I could not refuse. And so I came to Arizona State, and here I've strived since.
Fantastic. And what inspired you? What was your inspiration to pursue a career in maths and stats?
My inspiration really came on the shoulders, on the help of others. I didn't really know what maths was, other than calculating the numbers. I didn't know what statistics was. But people like Dr. Sincere, Dr. Farrell, Mr. Puadas, Dr. Richards, those people somehow came into my life at different times, but they said the same thing. And because of that, I went forward and with statistics because they made some comment that really stayed with me and made a whole difference in my life.
So, with their influence and with all of the years of experience that you've had in the world of statistics, tell us what excites you and what should excite others about statistics.
Well, it's a little bit of excitement, it's a little bit of comfort, and it's assurance. One, statistics transcends every discipline. And that's great to know that you're a statistician and you really have that power to transcend other disciplines. Young people, it's like mother making roti or making a pillow and forget to put in salt. It never tastes the same way. But that statistics is like the salt of the world, the salt of the discipline, the salt of research, the salt of making profits. It's really that important to be a statistician and to be talk about statistics. So with that alone was a key to exciting me. But just knowing that I can do this and knowing how I could help others to do the same thing, they all come together to make my life a satisfying one.
Well, thank you for that insight. And with that in mind, how important do you think events like UWI's Math Fair are in promoting interest in maths and statistics, especially among young students?
50 or 60 people will attend, and that included teachers. But now I see 4,000 plus people attending at there in Trinidad. And I think that alone shows the great interest. And I think it's really an exciting event that Dr. Tripathi, sorry about that pronunciation, and others are doing in this area.
Well, congratulations to Dr. Tripathi and everyone at the Department of Mathematics and Statistics for hosting such an outstanding event. And Professor Wilson, how can students benefit, really, both academically and in practical ways from studying statistics?
Well, statistics, my favorite comment is that statistics transcend every discipline. And being a statistician in itself is important because other areas, you can be a statistician in health. You can be a statistician in law. You can be a statistician in education. You can be a statistician in chemistry and sciences. You could be a statistician in engineering. You could be a statistician in several different places. You could be a statistician at the Bureau of Statistics. You can be a statistician at CSO. And you can be a statistician at university. So whether you want to be an academic statistician or you want to be one who influence profits and influence the way of life, elections are important that statisticians give you a glimpse of the future, and they give you a glimpse of the future in several different areas of life.
Having a glimpse of the future is so very important. Thank you for highlighting what a critical role statisticians play in in so many disciplines. And can you highlight, because you were once a part of the Faculty of Natural Sciences, as it was called back then, can you highlight some of the programs available at the Faculty of Science and Technology for students interested in math and statistics?
I wasn't correction there, Laurie. I wasn't really a member of the faculty. I was a member of the student body. But since becoming a professor here, I will only look back and see the things that are happening in Trinidad. And just recently, I had the opportunity to visit there. I was as a guest of Dr. Tripathi, and he talked about the areas there that you have. And I realized that there are similar areas that you have down there, some key ones that you mentioned earlier, Laurie, where statistics play a key role, where you can go there and get a good understanding of statistics on the campus. Again, I met with the Professor Ramnarine. He was there at the beginning of my 2-day workshop there, and learning from him, he was pointing out the opportunities that you have in statistics. So you have a few areas that you could learn about statistics, and you could put forward right there on the campus at UWI. So yes, you do have several areas, but I hesitate to name them, lest I forget some.
Sure. Thank you for that response. And there are, as you mentioned, thousands of students listening in. And with the many lessons that you've learned over the course of your career, what advice would you give to those considering a career in mathematics and/or statistics?
Maths and statistics, especially today, young people, you have here about ChatGPT, you have here about AI. All of these are areas that you need statistics. You need a statistician. You hear about big data. That's really something that's really born out of a statistics department. Many times we tend to lose, as statisticians, we tend to lose our identity. But when you stop and think about it, big data, AI, ChatGPT, they are all areas that really belongs to the field of statistics. So as you reach out there, you cannot, as I said to you earlier, you cannot make a mistake doing statistics, because that's something that everybody needs. And if you find out that you want to switch and go to something else, you'll be taking a very good preparation with you. So you could be a statistician and you could be in several other areas as well. And but we have a shortage of statisticians here in the US. We have a shortage of statisticians in the world. And so you are not in the wrong place when you pursue a degree in statistics.
Fantastic. And it's also great to know that the University of the West Indies Faculty of Science and Technology, in addition to their degree in mathematics and statistics, they also offer actuarial science and economics and postgraduate degrees in math and statistics. So, Professor Wilson, if you were an 18-year-old with a chance to do it all over again, what, if anything, would you do differently?
That question comes up in many things in life. And I wouldn't want to do anything differently, because if I ask young people, do you know where we're going to be 5 years from now? Do you know where you're going to be 10 years from now? My present life dictates my future. And I'm glad that I had the privilege of running the UWI. I'm glad I had the privilege of going to Queen's Royal College, because that really make my future what it is today. So I'm happy looking back 2020 vision. There's nothing I want to change, because I don't know if I try to change it, what will happen in the future. So I'm pleased with what I am today. And folks, be pleased that you have the opportunity. Mom and Dad brought you here today. It's for this example here that you have, this however long you spend at UWI today, will help serve you or frame up your future. But what I will want to do, I won't want to do anything differently, Laurie.
Okay. Great. Well, as we bring this interview to a close, is there anything you would like to say to UWI's management and staff and those responsible for hosting UWI's Math Fair?
Yes. I would like to say thank you from me. I thank you from me because things that you have done made QRC. Things that you have done made UWI. The education you provided for me, that gave me the foundation to go on to Iowa State, to go on to Oklahoma State, to go on to Arizona State, and be the success I am today. So Professor Marie Antoine, Professor Ramnarine, Professor Kuban, Dr. Tripathi, and the Honorable Dr. Peter Smith. I want to thank you very, very much for what you have done. You don't know what difference it makes, but to me, my life is better because of things that you and others have done in the past. So thank you very much.
Thank you so much, Professor Wilson, and thanks to everyone at the UWI for inviting us to be a part of the Math Fair 2024. Thank you.
So it is a pleasure to be with you all here today. And I was very excited when I was asked to share with you a few experiences about mathematics and its applications, because I am an applied mathematician. So applying mathematics is what I do. And one of the things that I think very important is that we start to think right from a young age, how can mathematics affect my life? What is mathematics good for? These are some of the questions that I hope to answer, starting in a very simple way, and then I want to apply it to other things, like the sciences that we offer at the University of the West Indies, to give you an idea of what mathematics, what you can do with it. So why should I study mathematics? What do people do with degree in mathematics? So this is what I want to talk about. Can I make a decent living? And that's something that is a very practical question. It's an important one. How is it of benefit to me? And suppose I was to choose a major or minor in mathematics, can I pair it with something else? And these are the things that I want to talk about. Why do I even need math? Well, I claim that in our day-to-day living, I need maths. You know, when I go to the grocery with a limited amount of money, mathematics comes in very handy. Taking a bank loan, it is very important because we get bombarded by all these advertisements. This is a better package, take this loan deal. Well, if I know mathematics, I can check and I can see if the interest rate that they're telling me really is of interest to me. Deciding how and when to pay off my credit card bill, that is something that as you get older becomes very important, because sometimes you can't pay it all off at once, but you need to be able to check and see how much are they going to be taking in interest from me if I don't pay it off. Making smart investments, deciding how, deciding when, and deciding where to put the little bit of money that I might have. That is important, and an important application of mathematics for daily living. Another thing, mathematics in sports. I know a lot of the young men out there like sports. Do you know that if you decided to become a coach, you need mathematics? You need to check the angle at which you throw a ball, how to head it. You need to even check and see how to kick the ball. Does it work better if I kick it at the seam? If I kick it on the side or on the front? How to hold a ball when I bowl it? All of these I can use mathematical modeling to project, to see how the ball will move through the air. Usain Bolt, such a prominent athlete for the Caribbean, he would have studied how to make that bend in the 200-meter race. And do you know that you can study that with mathematics? You know, so even things like team formation, if you are an avid football fan and you're looking to see what's going on with Manchester United, and they brought in this interim manager who has a new formation, is this 4-2-2-2, is that a good thing or is it a bad thing? Do you know that you can answer that question with mathematics? T20 games, the cricketers among us, do you know that you need to calculate and see if I have a certain amount of balls left? Do I bat or do I block? This is a very important, and it's a mathematical question. Home decoration, for the enthusiasts out there that like to decorate, well, you need to know maths to know how much carpet to purchase if I need to carpet a room, or even to figure out how much paint to buy if I need to paint. You know, sometimes we bring in workmen to our house later as you get older and you have a job to do, you need to check, because these workmen tend to give inflated budgets and we need to see if it is realistic. Are they pocketing my money, or are they asking me to build more materials than what I would need for the dimensions of my building or my house or my room? These are things that are very important for someone to know. And if you are good at mathematics, it's a very practical application. There are other very important things. If you like to eat, you need to know how to cook. And cooking is important to know how to average. I need to know how to calculate ratios, how to double a recipe or how to divide it by 7. You know, these are important things. Sometimes I don't have the amount of ingredients that's called for in the recipe, and I need to decide how should I divide my recipe and calculate correctly. Because all of you who would have tried to make a cake, you know, if you don't have the correct ratio, your cake is not going to rise, it's going to flop. So estimating the amount of fabric for a cushion or a couch, these are other things that I need to know too. So yes, if I like to sew, I like to have nice clothes, I need to know as well how. How is it possible to buy the correct? So these are the things that I need to know. In terms of the, just a minute, I'm seeing here that, are you seeing my screen? Can you please just inform me if you're seeing my screen? Just so that I know that for sure that you are seeing my screen. Okay, so in terms of things like cooking, right? Right, so there we are on the correct screen now. Cooking is important. Estimating the amount of fabric for a cushion or for a couch, that's important too, right? Then moving on, because what I want to really talk about is talking about the applications with respect to science, right? So this is the area that I need to really zone in on, because I am an applied mathematician and I want to talk about the applications to science in the Faculty of Science and Technology. So if I was to pick a major or minor in mathematics, what can I pair mathematics with? That is the question that I want to help you to understand. So mathematics and physics. Physics is an experimental science, and it talks about the application of science to the world around us. And there are theoretical concepts like Newton's laws of motions that are described with mathematical terminology. The main branches of algebra, analysis, geometry, all of these things are extensively used in, and you need to know mathematics. Non-Euclidean geometry, do you know what that is? Well, if you want to do physics, it is the starting point of any discussion about relativity, which is a big area in theoretical physics and subject to a lot of study at the University of the West Indies. So if this is your interest, I would suggest that apart from doing a major in mathematics, you consider physics, right? Or vice versa, you like physics? Well, why not pair it with a major in mathematics? Okay, so what else can I do? Well, what about mathematical biology? And it is very true that many of the applications in mathematical modeling today have to do with biology, life sciences, epidemiology. And you would have heard that that's one of my research interests. I actually am interested in looking at the spread of COVID-19 and other such diseases. But did you know that you could look at the mathematical equations for the spread of a disease and apply it to crime? So this is another thing, you know, there's so many things that you can look at as an epidemic. Biofluid mechanics. If you look at rivers and streams and you see these little insects walking on the water, well, that's an application of surface tension. And in order to explain it, you need to build a mathematical model, right? And it will help you to understand how creatures move in water, how they walk on water, how they move through water. So the diversity and complexity of living organisms gives a great array, I would say, an array of applications for mathematical thought. So it is also an interesting thing. If I like biology, why don't I do a major in mathematics? What about chemistry? Well, for those of you who don't know, I also am a chemist. I did a major in chemistry and a major in mathematics. And later on in my PhD degree, I studied reaction kinetics and the motion, the stability of a chemical front in a polymerization reaction. So there are several applications in chemistry. So why don't you think, if you like chemistry, you like to mix, you like to match, you like reactions, you want to work in a lab, if you're good at mathematics, then it is a very good option to pair the mathematics with the chemistry and come out with something fantastic, right? So dynamics of hard, soft materials, instabilities, changing patterns and colors, coupled oscillators like on the screen that I have here, documenting the oscillating colors inside of a reacting system. This is all something that I can study with mathematical modeling. What about computer science? Here is another application. Do you like computer programming? And did you know that logic is the basis of any successful computer program? So it is something that I could do. Mathematical concepts are key to becoming a successful programmer. So certainly, as the mathematical models become more complex, then the computing resources that I have at hand need to become a factor. So I need to then build in computer science programming. If I'm a mathematician and if I'm a programmer, I need to know the maths in order to build my computer program. So they complement each other. So if you want to do computer science, I would suggest that you think also about a major in mathematics because it pairs very nicely, complements each other. And these two fields are the basis of things like data science, neural networks, right? So food for thought. You know, one very common application that people would say for mathematics is engineering. But I put it last because I come from the Faculty of Science and technology requires mathematics. We have another faculty in the University of the West Indies, that's the Faculty of Engineering. And certainly, if you are interested in engineering, you need to know mathematics because for your design of your bridges, of your roads, which is so needed in this country, we have so much potholes on the roads. Maybe if we could build a better road, we would have less potholes. You know, so it's important that every engineer is very well versed in mathematics. So if mathematics is your strength, this could be something for you if you're thinking about a career. Improved design for aircraft, rockets, and well, missiles. I don't really want to talk about it given the scenario in the world today, but mathematics really does come in handy if you have to design something, right? A bridge, a roadway. Detailed mathematical analysis is necessary before you implement anything. So all of this, I don't have much time that I could talk, right? They told me 10 minutes. I could talk all day about mathematics, but I don't want to bore you, right? So I am just going to end with one central thought. Now, this old gentleman on the screen there, I don't know if you recognize him, but he is one of the most famous astronomers. He was born in 1564, so quite some time ago. His name is Galileo, right? He is a physicist. He's an astronomer, well, was, and also engineer, but nobody ever said he was a mathematician. And here on the screen, I have a quote. Now I have surrounded it with fireworks because I consider this a very important statement that Galileo is known for saying. And I have it in Italian, but it means that mathematics is the language with which God has written the universe. So I leave that with you, just to think about how many things I could do with maths, not just in my day-to-day life, but if I was to decide on a science career, to think that mathematics would be a very good thing to pair with whatever I decide to do. So that's all from me. And if you do have questions, you certainly can send them to the team and I'll be happy to answer. So thank you for your attention and I turn you back.
It is my pleasure and privilege to address you today at Math Fair 2024. I, Emily Ramsahai, am a product of a BSc in mathematics when I completed my double major more than 30 years ago. I went on to work in industry, manufacturing and energy sector, and also in my family business, and then more recently in academics when I completed my PhD in statistics. My first slide here today speaks about how mathematics gives hope to people. And that is because we believe that every problem has a solution. This mindset has served me well both in my professional and personal life, even in my sporting activities when I played golf at the national level. And I invite you to adopt this mindset when you consider choosing your BSc. And the BSc in mathematics will allow you to do this. Passion is important in life, and there are 6 ways that maths gave me the passion that I have in my life. The attitude to solve problems gave me that creativity and that entrepreneurial spirit. Also, many inventions have been done by mathematicians, some of which you may know: Pythagoras, Newton, Einstein. They changed the world, and mathematicians continue to invent. In the future, we will continue to build on the works of these mathematicians in all walks of life. When we work with numbers and think in abstract ways, we stand on the shoulders of these great giants. So the work of these mathematical giants continue to be used in the future to build new inventions, to come up with new ways to work. And mathematics gives us the framework to represent all situations and all problems. It is a universal language. The intelligence that mathematics will bring you will serve you well in this technology age. The future is in making connections with existing things and using logic to do this. One of the most obvious jobs that a BSc in mathematics will prepare you for is a math teacher. This is a very stable career, and it affords you the time that you need to spend with your family or work on your career or even your side business. There are also other jobs you can look into. Presently, globally, NASA and Google hire a lot of mathematicians, and more locally and regionally, we see government agencies hire mathematicians. But in the recent past, a lot of private organizations are setting up teams that include a mathematician. And why you will see this in STEM. STEM is where you see science, technology, E for engineering, and M for mathematicians. Other teams that you can find would be also in finance, legal, medical teams where you would find a mathematician. Some of these require technical writing, it requires understanding data, it requires manipulation of models, and it also requires predictions to be made so that decisions can be made on this. This final slide that I have here today is our coat of arms at UWI. At the top of this coat of arms, you will see the pelican. A graduate of UWI has the Pelican Prize, and I invite you to join this group by registering for your BSc in mathematics. Thank you.
Hi, I am Dr. Ian Ford, a lecturer at the Appalachian State University, a university in the University of North Carolina system. I was fortunate in that I did all my professional qualification at the University of the West Indies, St. Augustine campus, a BA in mathematics, a MSc in statistics, and a PhD in statistics. I did my MSc in statistics and PhD in statistics with the Mathematics and Statistics Department at St. Augustine. While doing my PhD in statistics, I was fortunate to have a supervisor in Dr. Vijesh Tripathi, current head of the Mathematics and Statistics Department at St. Augustine. I say fortunate because Dr. Tripathi is very versed in survival analysis and biostatistics. He sets high standards, demands high standards, and is always available to render assistance. While studying with Dr. Tripathi, he and I published a number of studies in high-impact journals. When it came time to seek out employment abroad, my qualifications had to be assessed, and I was really proud of the number of accolades that the University of the West Indies could have attached to the assessment of my qualification. I always knew that entrusting my education with the University of the West Indies and the Mathematics and Statistics Department at St. Augustine was a good choice. Those of you who have decided to make that choice, excellent, and I wish you all the best in your future endeavors.
Okay, hello. Today we are joined by
Jonathan Brown,
and he's going to tell us a little bit about what this station is.
Yes.
Hello. Today we are joined by
Jonathan,
and Jonathan is going to tell us a little bit about what this station is.
Okay, so this is the sequential run. Basically, students come in from where you are standing, and they will meet table 1, right? Here, we have easier questions based on the level of the student, whether junior, intermediate, or senior. We will have certain difficulties. The difficulty of the question will vary. They will be timed, so stage 1 will have, they will meet a timer, and they'll get a piece of paper to work out their questions. Then, when they finish it quickly, they will move over to stage 2, in which they would get a harder question, same based on their level of education. And then we have stage 3 and then stage 4, right? If they win, I'll come to 7 minutes, they get a prize.
All right, so good. So right now we with Mr. Kwan, and we have, this is, what's the name of this game?
The maze.
The maze.
Yeah.
Could you explain it a little bit for us?
So we start at this. We start at this marker here, and you have to follow the direction where the arrow is pointing.
Right.
And you have to go in a straight line. You could also skip boxes, so you could go in as many.
So if I start here, I have
Yeah.
to go so.
Yeah.
Right.
Because the arrow pointing there.
And then from here,
You have to go here.
I have to go here.
Mm-hmm.
Right. And
Now
then
you could either take 1 step or take 2 steps, but it have to be in the same direction.
so I can either come here
Mm-hmm.
or go there.
Yeah.
And if I come here, I have to follow the arrow.
Yeah.
Okay, so I come to here.
Okay.
And
Yeah.
I come here. I
Yeah.
come here.
Mm-hmm.
So where's the goal? Where's the goal?
The goal is to end up in the center.
Or the middle?
Yes, the middle.
All right. Okay, so from here you go here
Right.
and then here,
Right.
but a stick.
Remember,
How come out of that?
you could
This is
skip
cheating.
multiple boxes.
Oh, you can skip.
So when you're here,
Right. I can come here.
you don't have to go there. You could go there,
come
or you
here.
could, yeah.
But if I come here, I have to go backwards. And
Right.
So if I come back here now,
Mm-hmm.
good. All right, so I'll come here.
Right.
And I can walk straight across the here.
Okay. Yes. Yes.
Right. And I have to go in the middle there.
Yeah.
Would anybody figure this out?
Yeah.
Like,
Every-
how long did it take to figure it out?
A good while. Some
Okay,
people
so-
figure it out quickly.
I'm going to reverse it. I need an arrow that pointing to there. Up in the corner.
Right.
So I get up in the corner.
Mm-hmm.
So how we get up in the corner? We gotta get here.
Exactly. Yeah.
So how we get here? By the way, you all understand what I do, right? I'm figuring it out. I'm not just jumping all over. So I look to where I need it to be. How I get there? I need to go in the corner. How I get there? I need to come here. So I need to come here. Now how we get to there now, boy? How we get to this one here? You see it?
Right.
So how we get to him? Boy, that hard, boy. Tell me, help me out, help me out.
Is it?
Is here?
Yeah.
Oh, look at this! We come here, and then we go here. Lovely. And then we go here.
Wait, but you start from here. But this was an arrow.
I didn't
Okay.
restart.
Okay.
I was continuing.
Okay.
Come over to here, and then now we go to the prize. The center in the box. Hey, here's our boss. Thank you very much, sir.
Thank you, sir.
Y'all, this was perfect. Hope you all learned something. Critical ability skills. You all understand what I want on here? We bring so many problems first with a little help from the boss man here. So excellent. Keep it up, man.
Thanks, sir.
Take care. All the best. Right.
Okay, so this game now, Jordan, tell us a little bit about this game. What is this?
So this is a maze, but this time instead of arrows, we have numbers. So the numbers tell you how many spaces to walk, but not necessarily direction. So you could pick any one direction and walk that many spaces. So here we have a 1 at the start square. So I could go one square in any direction, straight.
Okay.
So either here, here, or here. So say I come here, now I have a tree. So now I can go 3 in any direction. But I can't like go 1, 2, 3. It's only straight.
One consistent direction.
Yeah.
Okay, right. Okay.
You could do that.
Okay.
Asking.
I don't.
I think you could do that now. So, and the goal is to end up in the center square. So, let's see. If I have 1 here, so I want 2, I could go straight up. So that's 2. Could go 2 across. Then 2 again. Could go up. 1 here. But then forward send me all the way back.
So in the arrows game, Rajesh was showing starting from the end point and working our way back. The critical thing is
Yeah.
right? You think we could do something like that here?
Yeah, probably.
Okay.
So if we're in the middle, to reach the middle,
Or we want to start?
yeah.
Or
So,
end up here?
so if I ended up on this 1, I could go there. So if I could somehow get to that 1, so how I could get to that 1? Well, I have no 1s next to it to say I could go 1 to here. So I could kind of look at the next layer around and see if it have any 2. So from here, I see a 2 here. So I could go 1, 2 like that. So you could try there. So now here, have a 1.
Okay, so we want to reach that 1.
Yeah.
So we had to be on this 2.
Yes.
And then from this 2, how we get in here again?
You can get from there, but I don't know.
Okay, 1, 1. Do we end up here?
Oh, we could go 2 here,
Okay, nice.
2 here. Yeah, 1.
Oh,
Right.
then that's it then.
So the solution will be from here. 1, 2, 2, 2, 1. Wait. Here. Here. Done.
Nice. Very good. Thank you, Jordan.
Okay, so hi. Who am I with?
Eden.
Okay. And what is this game you have here?
So the name of this game is IQ car. So the general basis of the game is to get this red car out of this little slot it has here.
Okay.
Right? So it has a few rules. It can't jump any few cars. It has to slide everywhere you go. It has to slide in the directions that the grooves are allowing it to slide.
Okay.
So we have a student here.
Yeah.
Wants to try to figure it out. This is one of the harder ones.
There's a harder one.
Yeah,
So you
it's
giving
one of
them
the
a hard
harder
one?
ones.
Yeah, we give him a harder one.
Well, we gave them the hardest one before, and they figured it out.
All right. Okay. So they should get this then.
Yeah.
So what exactly is your strategy?
My strategy is to do it over and over until it works.
All right. Brute force. Okay. Yeah.
Proof by exhaustion. Your car's kind of.
Yeah.
Your car's sticking up.
Kind of sticking out.
You need to bring them back to mechanic. Which way you should go?
I don't know.
Now, pull this back.
Looking like you're making it worse.
Right. Pull that back. Bring the handcuff on. Bring the handcuff on. Right. No, they're not. No, they're going. This come out. No. So, here. And then.
Because of what would move with the 16. I love your
You just need to get this out. So everything will need to come out.
Yeah, that's the thing. You're ready for stuff.
Right?
Yeah.
Which? Sorry. do that. Then
1 over 18, I like 1 over 18.
Right.
Okay.
Right.
Yeah.
Sorry.
Almost.
Wait, don't touch that.
You don't move the red card.
You don't move the red card.
Right.
They're giving hints.
Right.
Yeah, a little bit of it. Yeah, pull this out.
Too big.
But this can't move.
Yeah.
This can't move. This one back.
Okay, so we just said 36 is too big.
Right. From here. Probably here. No, not really move from here. No. This has to stay here. Right? This will come here. This will go up here. Right. So where are we going from here? We need this to come down so it's all down.
So I would have multiplied top and bottom by 2. Right. So that's 14 on 18. Right. Since alright, let's assume that 1 over 18.
Can I stick up there?
Play minus 1 over 18.
If they figure that out before you all.
We get 13 over 18. We now need to make 2 fractions to add up to 13 over 18. Now they explain how they play. Now if this don't work, we have to multiply top and bottom by 3 and see if that works. And then 4.
Okay, so we have Miss Karina here with us. Karina, could you explain what this Egyptian fractions is?
Sure, no problem. So, right. So over here we have Egyptian fractions. So we're gonna choose a fraction for you guys. We chose 7 nines here. And the motive of this game is to get 3 fractions that adds up to 7 9. So you have the numerators must all be 1. There's a catch. And next catch, you can't have 1 on 0. You can't have 1 on 1. This fraction must be bigger than this fraction, which must be bigger than this fraction. And that's the motive of Egyptian fractions.
Okay, nice. So let's see. Has anyone gotten a solution to this problem as yet?
Not as yet.
Okay. Does anyone of the students wants to walk us through maybe a thought process, what you're thinking? Anybody? Oh, okay.
Only 3 people won this game so far.
Them did 2 fractions?
Yeah, they did already.
Yeah,
they were good. Okay.
They actually beat out Jeopardy inside the JFK auditorium. They beat us out.
The thought process. Okay.
Hi, good day, guys. Hope all are doing well. What I'm thinking right now is just multiplying numerator and denominator by a number, so that way I could find the unreduced fraction. So if I was multiplying 7 and 9 by 2, I would get 14 on 18. We going on the assumption that 1 over 18 is correct. The basis for that, we don't know. So we're going to find out. Just I guess. Try things with maths. You know how it does go. So when we subtract 1 over 18 from the 14 over 18, I hope you're following. We're going to get 13 on 18. So we're trying to find 2 fractions to make this now. Even if does not work, if this doesn't work, then we're going to multiply top and bottom by 3 and then top and bottom by 4 and see if we could get it, assuming that this is still 1 over 18. So yeah. I hope they follow. I don't know.
No, they're supposed to be just here when they said that was there.
Okay, we're here with Mr. Daniel Rashid. Sir, could you please explain what you're doing here?
Well, this is the Department of Computing and Information Technology, and we are here playing some games, some computer science family feud, and the girls winning right now. The boys yet to score a point. I think they run when they saw the camera. That's all right, man. We're having a good time. Big up to the team that do math fair. Yeah?
Okay. All right, so this is family food. Walk me through your thought process a little bit. What's going on here?
So we was playing a game, girls against boys, and the first question was about what do programmers drink to stay awake while they're doing the programming thing. And then the next one is programming languages for beginners to learn. You're trying to guess everything. Right now, I guess 2, but I can't figure the 3 other ones.
Okay, well, hopefully you get through with the rest. Thank you, guys.
Okay, so what booth is this?
This is the engineering booth. The
Okay.
engineering booth for the Faculty of Engineering.
Okay. So
right here we have some information on the programs that we have. So, any engineering program you want to get into, we have these documents. So the students know what requirements they need, what subjects they need, what grades they need to get it. We are advertising our engineering youth camp right here for 13 to 16, and they can build devices like these, right? Program them, learn about the physics behind them and the electrical part behind them.
Okay, so this can actually work?
Well, this one doesn't work. It's not programmed.
Right.
Right?
Okay.
Right? But
Same with this one?
we can work. Yeah, same with this one.
Okay,
We
okay.
can work if you join the boot camp, right?
Yeah. Okay.
And, well, here we have like a Lego demonstration of a plant, right? A chemical plant.
So there's a process plant and laboratory and a gas transportation station. Okay.
Just a little Lego demonstration of the plant and how it's worked, the different stuff it have inside it. And then, well, all this is part of the engineering faculty. So you can learn more here. That's geoscience, different types of rocks.
Oh, okay. So
And the real rocks as well, like you can have obsidian right there.
Okay.
Like actual obsidian. So you
That's
can,
the black one?
Yeah.
Okay.
The Department of Chemical Engineering within the Faculty of Engineering.
Okay. So what kind of these pictures
Yeah,
and stuff?
so we use geoscience to also help tell us about Earth and Earth history. And in this case, in these pictures, we just have a few fossils. Fossils was something that were once living that's now preserved as a rock.
Okay.
And we kind of just ask the kids to choose different fossils so we can tell them a bit about Earth history.
Okay. So these are real fossils?
Yes, these are real fossils. Here
Okay.
we have an ammonite. An ammonite went extinct same time as dinosaurs. So here you can see the trilobite, but you just see his back, not his head.
Oh, yeah.
His
I
back
see it.
there.
Okay.
There's a fern leaf. You can actually see just like a fern leaf that you'll find in your yard today. It's an older one. This one is one of my favorites. It's called a stromatolite. They had this cyanobacteria that helped oxygenate the earth, and it was preserved in like these small layers.
Okay.
You still find some of this stromatolite is the name of what they form. You still find them in modern places today in Australia.
Okay.
And this one's kind of neat. See, just like this one, it's a piece of a dinosaur bone.
Oh, really?
You could actually see kind
Okay.
of part of the dinosaur bone. All those who like gaming, they always know some of the rocks that they use to build for, Minecraft and
Oh,
different
yeah.
games.
That is the
There's obsidian,
Okay, yeah.
granite. Pumice that scrub your foot actually also comes from explosive volcanoes. So it gets air bubbles if you lift it. You see how light
Oh, yeah.
it is.
Okay, this is
Like,
very light.
Yeah, it's very
Okay,
light.
okay.
And well, this one makes everybody laugh. It is what you think it is.
Really?
We call it coprolite.
Coprolite.
Yeah, but it's actually fossilized.
Okay. And what?
So, in this display here,
Yeah.
in our program, we also offer courses in geophysics. And we also learn how to interpret the Earth using layers. So, using sound waves and based on density contrast of different materials in the Earth or the layers beneath your feet, you can then create imagery, and we can interpret that imagery.
Okay.
All of this encompassing all together helps us find petroleum or hydrocarbon, as well as reservoirs that we could then pump carbon dioxide back into the Earth. So in the program, you learn about how to sort of interpret the Earth and the subsurface, and then also apply it towards industrial use.
Okay. Nice. Sound good?
You're welcome. Thanks for stopping by.
Yeah.
And at this station, we are joined by Mr.
Matthew Singh.
And Mr. Singh, what are you doing here?
So, I was asked by Matthew to come and display my club, right? My club is esports and gaming as well. A lot of the games we have incorporate a lot of strategy as well as logical and analytical thinking. So beforehand, right now we have the students just playing games and relaxing, which is a large part of our club, taking the edge off and sort of just chilling and balancing academic life. But beforehand, we had a display where we showed them how to program in Scratch. And Scratch is a game where you could program a game within the game itself. And it's kind of cool. You can do a lot of cool things with it.
Okay. You can maybe show us the Scratch thing?
Sure. You mind if I show us? Show them Scratch.
So in this program, we don't do traditional code lines and whatnot. We have different segments where we could code based on the color as well as the different shapes on the blocks as well. So I won't go through the syntax, but essentially what all this stuff is here doing is programming this little guy in the corner here to move, right? And when we click this green flag, it activates all these code blocks where the green flag is located. And each of these code blocks is like a pivotal functionality for this program here.
Right.
So this block over here, being that it's colored blue, it doesn't allow the character to move through it because it moves you back 10 spaces while the arrow key moves you forward 10 spaces. Right. The green one allows the character to advance to a different phase of the program. So that's just upon touching it. Right. And then the red one, whenever you touch it, it sends them back to the start. So this is like an error, or like you died in the game, you know. Right. So you could program, you could do a lot of cool stuff as well. You could do like Flappy Bird or Geometry Dash as well. Yeah. And yeah, it's real simple as well. Like to build a stage, all you need to do is like come here and then go to the backdrops, and you could design it like in MS Paint. Oh. I could do a lot of cool stuff like that. It's real simple, very easy way to get into the programming and coding and stuff like that.
All right, thank you, sir. We'll move on to the next booth.
So hi. So which booth is this?
This is the Department of Life Sciences booth.
Okay.
So we're representing degrees in biology, in environmental science, and in biochemistry.
Right, okay.
Which is all here, exactly. Right. So we also are representing our zoology museum, which is a museum with a collection of research specimens that we have within the department.
Okay,
so
all of this is in the department.
Sorry?
All of this is stored in the
department. Yeah,
department.
exactly. We have a whole museum inside the department full of all these specimens. We just brought a few out to show people today.
Okay.
Yes, but it's a collection we use in research.
What do you have here?
We have here a turtle shell that was donated to the museum as a specimen, and we actually have a lot of these inside the museum. They would normally be illegal to keep by an individual because they're a protected species, but we have the permits to have them in our collection for research. Yes. And then we have some specimens here that are not from Trinidad and Tobago, but we have them because they are really interesting to show people other species from around the world. Like this is an elephant foot. So we use these to kind of quiz students. This is the sole of the foot of an elephant.
Okay.
And this is one that we try and challenge students with to ask, what is it?
What is that? I don't even know what orientation.
You'd want it this way, yes.
A tooth?
Yes, it's a tooth of what?
Of shark?
No, it's very heavy. If you feel like a shark wouldn't be able to swim well. Yeah.
Okay.
So this is a clue actually. It's an elephant tooth.
Really?
Yes. So this is just one of, I think they have like about 8 of them in their mouth. They're really heavy, and that's how they would chew on grass and the plants that they would eat.
So it's kind of like molar.
Yeah, exactly. But all their teeth are like that because that's what they eat. Yeah.
Yes.
But they'll get worn down over time. So that's And anything else? Yeah, these are all other specimens from the museum that we use in research and education. So these are native butterflies. People are often surprised to hear that we have nearly 800 species of butterfly in Trinidad and Tobago.
That is a lot.
It's a lot, it's a lot. And the same thing with bats. We have 70 species of bats in Trinidad and Tobago, 70 different species of bats. Okay. And they all play really important roles in the ecosystem. And we have a lecturer who teaches on our programs, Dr. Roston, who's expert in the bats specifically.
Okay.
So we go out and we trap them, measure them, identify them, release them as part of our research program.
So this is
this one.
This was an actual bat? Or?
Yeah, this is a real bat. This is the largest bat in South America. Okay. This is Vampirum spectrum. It's not a vampire bat, but it is the only carnivorous bat in the world. It actually catches rodents and birds and eats the flesh of other animals, which is very unusual for a bat. So they're probably not that rare, but they're very hard to see. That you see them in arena forest, and they live inside tree trunks where they kind of eat their prey. So that's a really, really cool species of bat. Yeah. Here we have just a sample from my insect collection, showing you some. These are wasps, little wasps. Just part of our collection here.
This is a honeycomb, or look, because I mean,
I think this is a wasp nest actually, not a honeycomb, but it has the same honeycomb there.
Yeah.
But we have like hundreds of drawers like this in the museum, full of specimens from more than 150 years old.
Okay.
That have been collected by different generations of researchers over the decades, and we still use them for checking for research and things like that. So anyone can make an appointment to come and visit the museum and have a look.
Okay.
You can check online the UWI Zoology Museum. We have a Facebook page and an Instagram. So we've got lots more to show. It's just a little sample of what we have in that museum.
Thank you.
Yes, you're welcome.
Take care.
Okay, and joining us now from the Department of Physics, we have...
Karishma Fasad.
Okay, Karishma, could you tell us a little bit about what's going on here? I see you have...
The liquid you see here is liquid nitrogen. That's why it's smoking. It's very, very cold. And what happens when we put the magnet on the superconductor when it's that cold is that it floats, it levitates. So what happens is that the superconductor, when it gets cold, it creates a magnetic field that is opposite to that of the magnet. So it flows. We like to hit of it with the something like a bullet braid.
All right, sir.
Okay, so in this game, you're supposed to memorize all the colors and patterns of the shape, and then try and put them together by memory. So,
How long do you have to memorize?
as long as the one has been figured, it's starting to get a little harder. Yeah.
So this numbers, the more stars is the higher the difficulty.
Yeah. It goes all the way up to 5 stars.
5.
I can only stop at 3 stars.
Yeah, but yeah.
And that's when I realized I couldn't do 4 stars.
So what game is going on?
I don't know about the part. She could explain about
optometrist today. Brittany, so what are you doing here today?
We are checking vision. What we're doing is checking your name and information.
Okay, nice. So, do we have a live example here? Okay, so at this station, we're joined by...
Aliyah.
Okay, Aliyah. So, what is this?
This is the corner bridge puzzle. Basically, what you have to do, you have to be able to cross all the bridges, and you're only allowed to cross the bridge once. You cannot go back and cross that bridge more than once. That's the little trick of the game.
Okay, could you maybe give us an example of a walk through the paths?
So basically, you could basically start from any one of these 3 bridges, and you can take any pathway, but you're only allowed to cross a bridge once. That is the most important thing. There's a trick behind the game, but there's one specific trick behind the game.
Okay, so we see here. So we started here, we crossed this bridge, this bridge. Which bridge we going on now? Okay.
Have a go?
Okay.
Anyway, if you solve it, I will buy you KFC.
Okay, if I solve it. Alright, so we're starting here. We're going this bridge. We're going this bridge. Come back on this bridge. You said we could cross each bridge once, but what about the lands? We could be on the lands more than once?
Yeah, you could be on the land more than once.
Okay. Okay, go on this bridge. Oh, go on this bridge.
Okay, next.
What's going on here? You said it had a trick to it? What's the trick to it?
Hey, what? Try. I'll give it 2 more tries. If you can't get it before then I'll
Okay.
tell you.
So, let's start here instead.
Okay.
I think it's shrink kind of.
Yeah.
We can start here. We can come here. We can cross here.
Right.
Okay, let's start here. Come here. We go here. We go here. We go here. Oh no. What happened to that guy? Okay.
You're missing a guy.
So what is the solution?
The trick to this, there's no solution.
What kind of setup is this?
Well, no KFC for me, I
There's
guess.
a odd number of bridges, therefore the game is unsolvable. It's just a trick people and get the mind thinking.
Nice.
Actually, we had a Form 6 game, he watched it, 5 seconds, solved it.
Interesting. So that's a little bit of graph theory for you all there.
Okay, so hi. What booth are we by?
We are by the Actuarial Science Boots. Actuarial Science Club.
And what game do we have here?
Today we have the the Tower of Hanoi. It's a game where you have to follow the 3 simple rules.
Okay.
Where firstly, you can't have a bigger piece on top of a smaller piece like that.
Right.
Secondly, you could only move 1 spot at a time using 1 block at a time.
Okay.
From here to here or here.
Okay.
And the objective of the game is to build this pyramid on either one of these 2 slots.
So recreate.
Yeah, to recreate it on either one of the others.
Okay. So okay. So if we start back. Right.
Okay, well, this is not the one.
Yeah. So. And then now I want to move this. I can't move it here.
No, because this one is bigger, so.
Yes. So it had to go here.
Yeah.
But now I can take this back and put this.
Yes, you could.
Okay.
As long as it's within 1 move.
So okay. So
Yep,
I wanna-
that's fine.
Can I make back this small one?
You could.
But then I can't take up the 2.
No, 1 at a time.
So I can move this over and then move this.
Yep.
Okay. Then like that.
Yep, that's fine.
So I'm going good?
Yeah, you're going
Ready for the
amazing.
solution?
You're doing
Okay,
great.
okay. So that. Put this here. Right.
Yeah, you're going good.
Yeah, okay. Right?
Right.
Looking like progress.
Amazing progress.
Okay. So
Yeah,
last one.
now the last guy needs to come out.
Yeah. So people getting through this so far?
Yeah, someone actually solved it in 2 minutes, 3 minutes. The longest
okay.
was maybe 12 minutes.
12 minutes?
Yeah.
They committed?
Yeah, they did complete. A lot of people didn't though.
Or did they give up?
No, maybe it was a time constraint with their school.
Okay.
Great.
Oh, yeah. Right.
Yeah, and that's
So,
the
okay.
principle of the game.
Way back.
What?
Yes?
Yeah, that's it.
Thank you, thank you.
No problem.
Was that a fun game?
Yeah, it's a pretty fun game.
You solved it?
Yeah, I solved it.
Well
I don't
done.
remember my time, but
Okay. Alright. Well, thank you.
no problem.
So we have one of our sponsors for the 2026 UWI Math Fair, Domino's, and we'd just like to ask them what they liked about today and what the UWI Math Fair meant to them.
Well, I mean, we are very happy to support the youth of the nation and to support the math fair. I mean, it's important. It's very important to the students of our nation. So we are very happy to be supportive.
Thank you. Okay, and joining us, our Unipet representative, Miss
Shania.
Okay, Shania, what did you guys do here for the students today?
Well, we had a Math Jeopardy where we have 3 different categories, and they can choose any point that they want, and then they got prizes based on how many points they got. We had coloring books, Unipet coloring books, bags, and bottles. So we had a fun little session today.
Thank you.
You're welcome.
Okay, so today we are joined with
Liana Ali.
okay from Unipet, and so what does Unipet support in the math fair mean?
So today our appearance here was very intentional. We believe that students here, as well as the education system, it is the biggest investment we could make for in terms of education and for persons here. So we are actually happy that UE also does this partnership with us, and we are proud to be here and represent Unipet.
Okay, and we are happy to have you.
Thank you.
Thank you.
Okay.